So welcome everybody. This is the ETL tutorial. So I hope you are in the right place and excited to learn about data standardization to the OMOP Common Data Model. Yeah, man. ETL is the best tutorial ever. So we've got quite a few really great presenters and instructors for you today, but we do like to make this more of a conversation. So at any point, if you have questions, clarifications, please let us know. We are happy to chat and kind of like go in the direction we need to go for the room. So really not super formal here. We're all friends. We're all going to have fun. So what we're going to talk you through today is just a suggested process for how you might develop your extract, transform, and load process. We're going to take you through a couple ETL tools that are open source and available for you to use. These are optional. Of course, you do not have to use them, but it's a nice way for us to take you through how we typically create an ETL. We're going to share with you some resources like the Book of Odyssey, like the Themis Convention Library, among others. And then we're going to generate a simple ETL. And I'm really excited because we've got a couple new instructors this year who are going to give you some additional information about other ways you can develop an ETL as well. So here are our instructors. So that's myself, Claire. We've got Maxim here. We've got Max, Evanette, and Karthik, and of course our lovely Pusheen, who you will see in our slides, courtesy of an ETL tutorial alumnus, Erica Voss. All right, so we do have some breaks built into our agenda today. So please just try to return on time. I'll just show you the agenda here. So I'm not sure if our breaks are going to align 100% with the break that Elise and the organizing team put together for you. So we do have snacks in the middle of the table, so please feel free to eat as much as you want. It is Halloween season here in the US, so we wanted to share with you some of our really fun Halloween candy. So we're gonna, like I said, we're gonna take you through the OMOP CDM and vocabularies with Karthik. Evanette's going to show you our synthetic data we're going to be working with today. Then we'll have a quick break. We're going to take you through then the actual ETL logic itself. Now that you have a basis of the CDM, we're going to walk through how you might put together the ETL for the 4 or 5 main tables, and just to give you some approaches and techniques that you would want to use to build your ETL. We'll have another short break, and then Max is going to take you through how to generate a CDM, what other tools and technologies are available for you, and he has some really nice offerings to share with you. And then Maxim is going to take you through how to evaluate your CDM from a data characterization and data quality perspective. So you can see here we have an end time at 4:35. So technically we have this room until 5 o'clock. So we do have a nice buffer in there for Q&A throughout the day as well as at the end. All right. So I'm going to put this up for you while you guys get situated here. I want to do a quick show of hands just so we know everybody in the room kind of where we're coming from. So can you please raise your hand if this is your first Odyssey Symposium? Oh, that's fantastic. Welcome. We're so happy to have you. Let's see. Please raise your hand if you have data that you are working to convert to the OMOP CDM. It's not quite there yet. Oh, great. You are in the right place. Fantastic. Let's see. Please raise your hand if you already have an OMOP CDM instance. Maybe you've inherited it from someone and you're trying to understand it. Okay, we've got a few folks there. Fantastic. So hopefully we can help you there as well. And let's see. Can you please raise your hand if you have not yet started your conversion to the CDM and you're just trying to learn as much as possible? Anybody in that boat? Okay, we've got a couple folks in that boat. Okay, so really it seems like we've got quite a few folks for whom it is their first Odyssey Symposium, so welcome. We're super happy to have you. All right, and I'm going to go ahead and hand it off to Karthik, and he's going to take you through some foundational concepts of the CDM and vocabulary.
Thanks, Claire. Oops. Can everyone hear me okay? Okay, great. Let's just see here. So I like this set of slides. I won't take credit for it. I think Christian might have created it years ago, but just to give some context of why OMOP, why a vocabulary, it helps me at least when I think about this, because like every local institution can do whatever they want. The current approach is one study, one script, right? So you have, this, you could say this study, you want to look at adherence to a drug. This is the data connection. And say you want to run this analysis on various data sets. So in the past, you'd have to build out multiple scripts for each data source and kind of go through your own vetting there, right? Here comes like OMOP, which is really saying, okay, well, this is our current standard where we have all like basically a rat's nest when it comes to trying to put all this together when you have to like do a multi-site study or analysis. With OMOP, you're able to standardize the data, right? So then you might have one script that's really connected to multiple data sets and you're writing code once. We all know from a practical point of view, there's always little tweaks, but on the most part, you're writing majority of your code once and you're just executing in multiple sites. And so now you can run multiple studies and not really, and you reduce that amount of time that takes to run an analysis. And so you can iterate on multiple studies at the same time because you have the same data set, or data format, I should say. And so this is just examples of various analyses one might run over time. This hopefully gives some people a context, because when I'll talk to other people, they'll be like, well, I already have a warehouse, or I already have a data model that I'm using for, I don't know, for my anesthesia cohort, and we have a small consortium of people looking at anesthesia. Well, the thing here is you can answer multiple questions on a very large general population. And I think that's where the power of OMOP comes from. And one of the underlying pieces of OMOP is the OMOP vocabulary. So one of my day job hats is working in the analytics, or working with the analytics group at our hospital. And, this concept of a vocabulary doesn't exist. And to me, I was like, I don't really care about the data model. Like, we can create a bespoke data model if you want for operational purposes. I'd probably leverage some principles from OMOP, but at the end of the day, I want a controlled terminology, and that's what the OMOP vocabulary is. It encodes data at a semantic layer, and that's very important when you think about standardized analytics, because you can put data into a database table or whatnot, but until you've coded it and you've semantically aligned the data, it becomes very hard to do analyses. So just as a reference, a little bit about the common OMOP common vocabulary model. It's not its own vocabulary. OMOP really tries to leverage existing public vocabularies, and where there's a gap, we fill it. So the general rule is that we leverage what exists and we don't try to create something bespoke. It is not a static data set, meaning it is community run, right? So we're not saying, okay, here's the vocabulary, we're not touching it again. Actually now twice a year it gets updated, and that's because of more upstream vocabularies getting updated. So SNOMED and ICD or whatnot, those terminologies get updated, and as a downstream effect, so does the OMOP vocabulary. So whenever someone says, oh, well, that's the OMOP vocabulary, I kind of have to correct them, saying, no, well, we're just an aggregator. We have a few concepts that are OMOP specific, but on the most part, it is the source system and their source vocabularies. What we do, however, is standardize on the vocabulary. So we have, obviously, from a history lesson, OMOP and Odyssey kind of came about through a a partnership between pharma and the FDA, and so around like surveillance. So a lot of the vocabulary right now is around drugs, and that's where it's been vetted out quite a bit. But there are other vocabularies that we're expanding on. So if you look at blood transfusions or ISBT codes that are in the OMOP vocabulary. We have standardized on many other things, and I'll get that to the next slide. But currently, there's over 11 million concepts in the vocabulary, and every quarter or twice a year, that vocabulary gets updated, and there's new standard concepts, which I'll get into a little bit later. So this is the vocabularies by domain. So you'll see you have SNOMED. There was actually a paper done by Christian and the folks in Odyssey who showed all the various vocabularies, where their capture was, and how they made the decisions on why they standardized on SNOMED. SNOMED was international. Every country has it and can be applied. Their data can be mapped to it. And SNOMED has the biggest coverage across all the various domains. And when we say domains, we mean the individual tables in OMOP. And you'll see there, most of what we're looking at and what we do is actually standardize to the OMOP vocabulary. So if you look at an individual record in the concept table, excuse me, we'll look at atrial fibrillation. You have a concept ID. You have a descriptive name for it. The domain, which is the condition domain in this case, and it tells you what vocabulary it's from. It's from SNOMED. You'll notice there's a field called standard concept, and OMOP or Odyssey, OMOP really relies on data being tagged by a vocabulary concept that is standard, and we have mechanisms to actually turn that around. So this is just an example and description of each of these. And the concept code is the source code for that source vocabulary. So there is provenance in everything that we do, both in the CDM and the vocabulary. So even though OMOP creates its own code of 313217, it's actually linked to the original SNOMED code. So this is general design principles when we think about the vocabulary. It's, a uniform structured. It is formally integrated into the CDM. There's relationships between concepts that are bidirectional, and that's what the concept relationship table is. And we'll get into that to the next section of how concepts are mapped to standard concepts. And there's a hierarchy that's built, which, again, we're taking existing vocabularies like SNOMED, ICD, and whatnot, and we're merging them into the OMOP vocabulary. So we're leveraging the existing hierarchies and adding additional ones. So if you look at drugs, we use the ATC hierarchy as well that maps to SNOMED codes. So you can say, hey, I'm looking for an anticoagulant, as opposed to having to list out individual anticoagulants. So makes analysis or analytics a lot easier. So going into source codes and source concepts and the mappings of such, these are just general kind of processes of how you might go about taking your source data and putting it into source code. And we, in the subsequent sections, will have a more detailed view of this. But really, if you already have something coded, say you have an ICD code, then it's an easy translation. If you have country-specific codes, like READ or ICD-CN, then the OMOP vocabulary has a mechanism for you to map to that standard code. The last two are a little bit trickier, right? Like if you just have free text, how do you go about that? And in a later section, we'll talk about how do we map that to a standard code. And then the last one is like, I don't have that code. I'm not finding this code in the OMOP vocabulary. What do we do then? And all of those we'll get into a little bit later. When you think about the vocabulary as a whole, you have non-standard concepts, standard concepts, and classifications. Non-standard concepts are ones like ICD-10-CM or ICD-10-CN. They're local codes for individual countries, but they're non-standard. And what we do is we work on mapping them to standard codes. And the classification concepts are hierarchy concepts. So you might have, let's take LOINC, for example, use LOINC codes, and the LOINC hierarchy codes are concept codes as well. Quick raise of hands, how many people are familiar with LOINC or other terminologies? Okay, all right, thanks. Yeah, go for it.
So the mappings between different vocabularies oftentimes are not one to one.
Yep.
So one to many, many to many, and many to one, other way around.
Yeah.
So can you just maybe walk us through general guideline and how you would approach that?
I want to repeat the question so that it can get on video. So let me just bring this to you to make sure we're capturing that.
Hi, thanks. So in the mapping from vocabulary to the standard SNOMED, the relationships are not always one-to-one. So one to many, many to many, many to many, and many to one. Could you walk us through some guidelines on how to approach that situation?
Yeah, good question. So you might have a case, and I think I have an example a little bit further down. You might have a ICD code that gets mapped to two SNOMED codes, for example, right? And how do you handle that in the ETL process? Well, we would say if they're mapped to two SNOMED codes, you put those two SNOMED codes that are both standard, because the vocabulary team has managed to say, okay, you know what? We really think this one code should be broken up to two. It's never perfect, and this is where we say like the data set is not static, it evolves. So this is, again, a community effort, so the vocabulary team is trying to do the best they can, and so when we find issues with their mappings, or we question whether it should be in this domain versus that domain, we usually raise a ticket in GitHub for the vocabulary team and kind of walk through that process of like, hey, does it make sense for this ICD code to be mapped to the SNOMED code in the procedure table and the secondary SNOMED code in the observation table? Maybe they both belong in the condition table, or wait, I think I found a new SNOMED code that actually does a better job of that mapping, right? So that's generally been the process. So it doesn't help us as in like an ATL developer who's trying to like make a decision right now, but it is, I would say the convention would be you follow what the vocabulary says as a first step. If the vocabulary says it's one to many, do the one to many maps to, and put the data in the correct domain tables. If you have questions about it, then raise that same question up in the GitHub issues section, and hopefully that'll get resolved. And you might even get like the understanding of why that mapping exists. I've had plenty of times where I've questioned things, and they're like, say, okay, well, if that makes sense, can you create a mapping for us? We provide them the mapping, and then the next iteration, the vocabulary gets updated, that change is reflected. What that means to us as ETL developers is that when the vocabulary gets updated, you're gonna have to rerun your full ETL. So like at Columbia, we now have an ETL that increments daily. And if I do a vocabulary update, we have a mechanism to do an in-place update, but we haven't implemented it fully, where we then have to do a full ETL update as opposed to do an incremental because the vocabulary's changed. So that is one of the kind of gotchas with handling the vocabulary. Did I answer your question?
Yes, thank you.
Okay. And I talked about standard, non-standard to standard. Going a little bit more into the concept mappings pieces. And again, my colleagues are going to go into more detail when we talk about these things. But again, I had those 4 layers of what examples are. Scenario 1, where you have your source code already has SNOMED, and you can just easily translate that into a data element in your OMOP instance. Scenario, and then this is where you can go to Athena, you find the code, and then you look up the value. So with the ICD code, you might say, well, there's a non-standard term, and it maps to Zika virus. So you can use Athena to kind of work through it non-programmatically to find out what those mappings could be, so you can understand it better. But there is a way to run that through just a query itself. So this is the other scenario where you just had the free text, right? Like let's take labs. You might have like units in centimeters. You just do a free text kind of search within the vocabulary to find the concept that maps. And this is the corresponding type of query that you might have. Oh, sorry, got too close. And again, you know, one could also say, hey, I'm just going to do the free text search here in Athena and have it return, but you can also run a query to do the same thing. When we talk about scenario 3, where it doesn't exist in the standard vocabulary and something's missing, open up an issue, right? So this is, you know, my plug again. It's an open community. People are actually looking at this stuff. If you put an issue out there and you don't hear much, you can just always ping someone, and there's usually someone who responds. And the lack of response is not because they're ignoring you, they have other things to do, but in general, what I've always experienced is there's usually a response within the week. And this is just even adding new vocabularies and having that discussion on whether you're going to add a new vocabulary. Say there's a vocabulary for a rare disease. How do we go about adding that? And there's sections about working groups that I'll get into at the very end. So going to the CDM, basic principles of the CDM, which might have been covered earlier in the morning session, is the CDM is patient-centric, meaning we're not focusing on the health system. We're not looking at, you know, how many supplies of some drug do we have in the cabinet. We're looking at what happened to the patient at a particular time and their interactions with the healthcare system. The CDM, again, I mentioned it before, is heavily dependent on the vocabulary. We have provenance kind of built into it, and the model kind of extends based off of the working groups, which I'll get into at the end. So this is just a quick view of the version 5.4 CDM. You can actually see documentation of the CDM and every kind of component of it, really, in the GitHub repo, which I think Clair maintains. So, you know, you have the best source of knowledge right here in the room. So the group put a lot of effort into documenting the CDM. If you go to the GitHub repo, you can actually click on a link and it gives you a GitHub pages, and it gives you a full kind of list of each version of the CDM, examples of how to like maybe populate certain data, meaning like what's the convention for it. Here's some basic information on the standard concepts when we think standard concept of the CDM table. So not talking about standard vocabulary, but more of how do we look at things. So when I said it's patient-centric, every table has a person ID, right? The core tables. You might have a location table and things like that, or the care site table, which are foreign keys into the person table, but predominantly most of the tables will have a person ID as one of their primary keys. The domain is used by, if you're in the condition occurrence table, you'll have condition occurrence _ ID. That's the primary key for that table. And so that is one of the kind of standard ways of how we added fields for each of the tables. If you dealt with anything with the vocabulary, if it's a vocabulary term, you'll have _ concept ID. So that's the way you know that you're dealing with a vocabulary related field. If you're dealing with a source system, you'll have _ source as the kind of suffix. If it's, say, a vocabulary for the source system, it'd be _ source concept ID. So we maintain that provenance, and also from a point of view of like understanding how, what do you expect by looking at each column? If you have a concept ID, you know it's a vocabulary. If you have source behind it, you know it's coming from the source system, just so you understand how the data originated. Okay, very quickly, because I know I only have 30 minutes, and I think I have 10 left. So taking an example, I put together this clinical case. You have a 51-year-old male, African-American, non-Hispanic male, who came to the ED on March 1st, 2024 at 312 with growing and abdominal pain. During the ED visit, it was determined the patient had kidney stones, received this drug and some morphine, and then subsequently had an office visit with the urologist, who then coded the patient with calculus of the uterus and had following lithotripsy. So you take this clinical case, and how does this end up in OMOP? Just for time purposes, I'm going to speed through this a bit. But you see we have the person ID in the person table, and I populated the fields accordingly to that. The visit occurrence, I put an arbitrary number because it's not a key that's unique for that. It's unique for that table, but it's not crucial for analysis, for example, right? It's going to be a reference to other tables through a foreign key reference. They came to the ED, so we have a code for 9203. That's the concept code for emergency room visit. We have the various timestamps, and in 5.4, or starting in version 5.31, date time was introduced because we wanted to get more granular time. So if you want to do an analysis, say, within a hospital stay, time makes a difference. If you're dealing with claims data, you don't have the time component. So we have both those fields, and that's why you have a start date and a start date time. They're essentially the same except for the time component. So if you look at the condition table, the vocabulary we map to SNOMED, but the patient came in and had an ICD code, and so that's what's mapped as the condition source concept ID. And then that gets mapped to the condition concept ID of 201916, which is the SNOMED code, or OMOP code that represents SNOMED for kidney stone. I'll skip this. Again, it's the same thing for the procedure. They had the lithotripsy, so we coded the CPT code and the time in which that occurred, and the data was originating from the EHR, right? So we have, like, if you have a data set from claims, your procedure type concept ID would be something that says claims data. But since we're talking about EHR data, there is a concept ID for the type, which would be EHR. Again, very quickly for the drugs, all the drugs are standardized to the RX norm vocabulary. So here we have this example where we have the drug concept ID. It was pharmacy dispensing because they were in the ED, and then we tag the source fields. So you have IV units, and that could be something what your local institution has, or your local institution doesn't have it, right? Like you don't have it nice, like cleanly laid out as IV or MG for the units, and you have to extract that, in which case you'd leave those units blank because those are nullable fields. The last table I wanted to mention, which is pretty crucial for all analyses, is the observation period. And I don't think we'll spend much time going into this because that's usually used for the other tutorials, but it is very important on how long do you think this person is being observed in your data. It's a derived table where we have a standard query that you can find on the same GitHub repo, where they say, okay, if you take the standard convention, this is a way to identify how long an individual is in your data set. So if you're in claims, you kind of know when they were on an insurance plan and when they were off and then when they were back on. EHR is much harder, right? Like you just have their data and you don't know how long you're seeing that patient. At Columbia, being in New York City, there's a lot of competition. And so we can't necessarily know if the patient is not in our data hasn't had a visit in the past 5 years, do we count them? Or are they just healthy and they just haven't had a visit, right? Like there are multiple things to think about. And so this is actually an active area of research. How do we handle observation periods when we think about analyses? But I wanted to put it out there because from an ETL point of view, you don't care, you want someone to tell you what it is, but it is so fundamental what you do when you put the data into OMOP that you get some of this stuff right, because when we hand it off to researchers, people just assume it's right and they run with it, and they might make incorrect assumptions if we don't have that done correctly. So there's two things that could be kind of confusing with OMOP, and I know everyone ends up having this issue, and that's OMOP tables combine data from multiple sources, which we talked about a little bit earlier. And then you had source data might be distributed over multiple OMOP tables, right? So you might have an ICD code that ends up in the observation table. And everyone in the US are like, well, ICD, it's a condition, it should just go in the condition table. And so this is like an example that I think maybe Erica put together years ago. I don't know exactly who did, but bitten by orca, initial encounter, because you might have multiple encounters apparently. And you see it has an ICD code. It's a W code, W56.21XA. And we said in the OMOP vocabulary, well, this is not really a condition. It's something that happened. Let's just put it in the observation table. So there is an actual method to what the vocabulary team is doing. They're saying, hey, this is not really a condition. This is something else. Same thing if you're talking about V codes when you're talking about ICD codes. The V codes in ICD are history of codes. So is history of something, is that an active condition? Or is it something that's observed that should be in the observation table? And so right now, the vocabulary team puts V codes like history of heart disease might be in the observation table because it might be history of your family history of heart disease. So that's not really a condition that you actually have. Okay, I'm gonna run through. I already talked about this previously. So last section is about related working groups. So one of the big ones is Themis. This is really the where I think a lot of the ETL groups ETLers should attend. One of the main ones. It's the group that comes up with the conventions of how to populate OMOP, right? If I have a particular data point and I need to get it into OMOP, they're the group that provides guidance on what's the best way of putting that data into the OMOP data model. We'll take an example of how do you get oxygenation. If you're in the ICU and you want to get oxygen saturation levels, what's the best way to put it into OMOP? They're the ones who come up with the conventions on how to populate it, or how do you populate the drug table correctly. So they'll come up with guidance, and the hope is that everyone else is following that. And they have a library of these guidances that you can find in the, I think it's in the GitHub repo as well, but there's also a Themis working group page that has this. So like that, they have that for every domain table for various fields, so you can get a sense of like what's the recommended way of doing it. And there are certain cases that are just still open for debate, right? So earlier today during the Vocabulary-thon, we were talking about how do we handle cultures? Like how do we represent cultures in the CDM? What's the best way to do it? And that's one of the groups that will end up putting that together. So this is just resources for the Themis working group. They meet the first and third Thursday of the month. There's their GitHub repo, and Melanie is the kind of the group lead for that. Other working groups for the CDM specifically is the CDM working group meets at least once a month. I don't think I have that on here. It's once a month. And so the CDM working group kind of, and Clair can talk more about it, is really the group that is vetting the versioning of the vocabulary of the CDM. So we're on 5.4. If we migrate to 5.5, it's the CDM working group that kind of makes that announcement, and it works with these other working groups, such as the vocabulary working group. So until the vocabulary adjusts things for particular needs. So for example, with blood cultures, we have to make sure the vocabulary is in line for us to handle that. Same thing with the healthcare systems working group. Again, I think Melanie runs that as well. If you're coming from a healthcare system, how do you extract that data? Challenges that you face when accessing your data, things like that gets discussed in that working group. And they meet every other Monday at 10 a.m. Eastern. But again, these are just resources and links for the various working groups. Vocabulary, CDM, Themis are the kind of core pieces of working groups. If you're in this space and you're starting to get into OMOP, I would highly recommend attending one or more of these working groups. And I think that's it. Hopefully I got it a little over time. Okay.
Hold on, there's a question. I'm going to bring you the mic.
So it sounds like some of the questionable vocabularies are reviewed manually. What about the rest of the majority of the codes or vocabularies? Are they automatically mapped, or are they manually evaluated, or based agreed upon evaluation? Because I work in the ontology field, so I'm kind of aware of that thing.
Yeah, let me see if I can answer your question. So, from my understanding, how the vocabulary team works is they first take the data from, like, say, the UMLS, right? The UMLS has all these mappings, but there's a lot of noise. So they prune that to the pieces that we care about, and then they enhance those mappings from historical work, right? So over the years, the OMOP vocabulary has evolved, so they do those updates from the UMLS, and then they have the set of, I mean, that's how they create the existing vocabulary. And they'll also look through the current set of issues and say, hey, you know, this iteration or this release cycle, we're going to fix these things, and we're incorporating into the mainstream of the vocabulary release, knowing that, hey, we're not going to be able to get to X, Y, and Z of these issues, which will have to be put in for the next iteration of the release. When you talk about, like, mismappings or vocabularies that haven't aligned properly, that we're really running off of community effort. So if you as an ontologist say, hey, you know what, I don't really think the alignment between this vocabulary A and vocabulary B are well suited, here's another suggestion. The vocabulary team will very much listen and probably try to get you to join the group. So, yeah. Any other questions? I know I zipped through a lot of stuff. Yeah.
How do you manage these vocabularies in terms of, say, if we have a study that happened on 5.1 and now we are on 5.4, how do you manage it, sending the data, or what to do with that? I mean, are you creating different instances of these vocabulary and creating the data for each of them?
Yeah, that's a good question. I mean, there's always this issue of versioning. So there's two types of versioning, right? You have the CDM versioning and you have the vocabulary versioning. And the vocabulary has two major releases every year. The CDM hasn't had a new release in a few years. So there's those two pieces, and I think it's up to the research network to manage that, right? So OHDSI provides all the tools and the framework for it. And so when we say we run an OHDSI study, one of the pieces of that OHDSI study is what vocabulary are all the sites what vocabulary are the sites on, and what version of the CDM are they on, right? And that's baked into, say, the protocol, saying if you're going to be running this analysis, we want to be in this version of the vocabulary and this version of the CDM. Depending on the analysis, your version of vocabulary might not have as much of an impact, meaning, like, say I haven't updated the vocabulary in a year, maybe that doesn't really affect your analysis so much, depending on your study itself, right? Like, maybe it's a pretty common disease that you're studying. We know that the vocabulary in that domain hasn't really changed that much. You probably get away with it. But that's really up to the group initiating the analysis and the study. But locally at Columbia, we generally, if we've done a study and we've published it, we archive the data set, and we have a storage issue. subsequent to that.
At J&J, Johnson & Johnson as well. So we archive our versions of our databases so that when we do get questions about historical studies, we can stand up that historical version of the CDM so that we know that that is not, any changes are not playing into our results.
Okay, so I was just wondering when it comes to if I'm doing like my ETL, and let me say I do have our source, my source data is not like, it doesn't have like one of the vocabularies that OMOP uses. Are there situations where like maybe the concept, maybe based on the granularity of my data, I try to map it to a certain concept ID, but it is not super specific. So maybe I try and map it to like a parent and not a child. Then I'm trying to think like if new vocabularies are released such that there's now a child vocabulary, like a concept ID that is more specific. And if I'm having in my ETL, my source data, where I have to do my source to concept mapping, I'm just trying to think, how can I be able to keep up with the new vocabularies? I think that's my whole struggle right now.
Yeah, no, that's a very real issue and struggle. I think each different groups do it slightly differently. You know, we have a small set of vocabulary terms that we've hand mapped. That we just have a random cadence, like we say once a year we're gonna do it. Reality, it's probably once every couple of years that we look at our mappings and say, hey, are there newer codes that we could be using? The other piece is like, you know, I gave that example earlier where there's different ways of doing the source to concept mapping, right? Like later you're gonna see a demo of Usagi. That's a manual effort to do that. One could say, well, Usagi is doing it's doing a fuzzy string match at the end of the day. If you can get away with like some other heuristic-based search, like you could do that within the vocabulary and say, hey, I got a new vocabulary. I have a set of queries to like find newer matches. Notify me or have a result that shows me the set of new concepts that make a match. And then rather than looking at like, say, a few hundred mappings, you might have maybe 20 mappings to look at when you do a new vocabulary. But it is a manual effort.
I'll say too, we do something kind of similar, but so for our manual mappings, each time we download a new vocabulary, we have kind of a standard process we use to say, okay, if we have manual mappings, you've got your source code, like your textual code, that you're mapping to a standard concept. So we take all of those standard concepts, we look at them in the new version of the vocabulary, and we look to say, did anything get deprecated? Meaning like, okay, that code is no longer standard, but there's a new one to replace it. So there are some processes you could put in place to look for those things and say, like you're saying, okay, I mapped to a parent, now a standard concept has a child. That is a query you could run using the vocabulary tables. Like you could set up some standard queries that you use for your use case each time. It's not necessarily something you have to do code by code. You could look in using some of the tables that are delivered with the vocabulary, like the concept ancestor table, to say, did any of them get new children? Like you could set up standard processes like that so you don't necessarily have to go through all of them each time.
For these vocabularies, don't we have the what's new? So that should dictate us what's changing or what's deprecating or what's getting added, isn't it? If we have a new vocabulary, there should be a what's new file or readme something.
Yeah, in the release notes, there's a new, like, it tells you updates to the vocabulary, but some of it, again, it's source systems, right? So they could say, okay, well, I'll take blood transfusions. The ISBT vocabulary got updates. We're not going to list all the updates because OMOP didn't do those updates. ISBT did those updates.
Okay.
So you can send a pointer to them. It's a lot of backtracking in those cases.
I get it now. Yeah, thank you.
Yeah.
Yeah, so a lot of times it's helpful to just say, bring in the new vocabulary, let me see what I have been using in my data, and then compare the new vocabulary to what I'm currently using, and like look and create some processes for your use cases. And there's quite a lot of information. I know we're not going all the way into it today. There's quite a lot of information in those vocabulary tables for you. I don't think there was a full vocabulary tutorial. I know they covered it in the intro, but there are some on the Odyssey YouTube channels as well that go more into what those vocabulary tables are, what kind of information they're giving you. So we're going to cover a very high level of the vocabulary, but there's quite a lot of detailed information about the mappings and ancestor relationships and all those things online for you. Yeah. Any other questions? These are great. Yeah.
So is it suggested, or I don't know if it's a stupid idea, but are we like better to have like a slow changing thing for vocabularies, or that's stupid? Or just like compare versions, like have separate files for it or whatever?
You mean like a diff between the two? Or?
Yeah, like this mapping exists between this date, and after that, this is whatever.
So there is a package. There's a package called Tantalus that I think Erica and Frank put together. So I know we run it internally and it basically says, okay, I'm going to compare the previous version of the vocabulary that we have to the newer one, and kind of is doing a diff to see which codes have changed. I know Erica posts after a new vocabulary drops, hey, I see these orphan codes. What's going on? Because I use some of them. So it is a very community driven, but yeah, there is some analysis.
Is like an output table for that? Is there a standard DDL for it? Like
That's a
we
good
can,
question.
like,
I don't,
like stand up, and every time something comes in, we'll just add to it. Like, is there something like that, or?
not that I am aware of. I just use that package to find out what the issue is, but oh, okay, it does. Oh, it's a very recent. So in Athena, you apparently can see the diff between them, but yours is saying over progression over time. What are those changes? Is that a standard
because we
table?
do some of that for our epic mappings, and I don't know. I'm struggling with the amount of effort I will do for that, or should I just leave it alone, or somebody doing that, or?
That's a good question. Let me follow up with you afterwards.
There is a researcher at Erasmus MC who has done a lot of work looking at the changes in the vocabularies over time. So we have now converged to these two major versions a year, but a couple years ago that was not the case, and it was a pretty consistent release. Now, part of that was because, like, say during COVID, for example, they were constantly releasing new CPT codes for vaccines, and we had to keep up, right? So we were getting releases like every week. But now we've converged to two. But a researcher, Tom Seinen at Erasmus MC, he has been downloading every single version of the vocabulary for years now, and he has mapped out how it's changed over time and what those differences are. And it can be very helpful. But usually what we do is the reason we've converged to the two major versions per year is because we're trying to make it easier on the community to say, okay, we're all going to move to the February version. Okay, we have 6 months, now let's all move to the August version. So that way it's easier for us to all be in step with each other. But it is a good point, and there's a lot of work done, like Dima Dimshits as well has got a poster around vocabularies related to phenotype changes. So there's a lot of work going on in the community to try to understand what is that impact of vocabulary change and how do we understand it and either document it or mitigate it. Great questions, everybody.
Yeah.
Anything else?
Okay.
All right, Evanette, you're up. Let's talk about Cynthia.
All right. So we are now experts in the vocabulary. We're now experts in the CDM. But you're here for ETL today, so we can't do ETL without data. So, you might be wondering, okay, what data are we actually going to use? We sent out some links actually before this course. Show of hands, anybody was able to access those links of the Cynthia data? Okay, a couple of hands, great, all right. No worries, we're actually going to be using them today. So you can also access the GitHub, and you can also follow along if you'd like with those files. So the data set that we're going to be using is Cynthia, and it's essentially a synthetic patient simulator. So Cynthia is an organization, or MITRE is the organization that creates the Cynthia data set. So they are producing realistic but not real patient data in a variety of formats. So you're going to have HL7 data, CSVs that we're going to be using today, and some other formats as well. But the best part is it's free 99, so we can use it. So what they essentially do is that they're mimicking patient records from birth to death. So you can imagine even in patient scenarios where you have like John Doe, who we saw earlier, that had those procedures and those visits that came in, you're gonna see patient journeys in Cynthia from birth to death. So you're gonna have some birth events, you're gonna have some death events, and things in between. You can configure different populations based on your use case. So you can configure the size of patients. So today we're going to be using about 100 patients in our sample. You can generate a population of 1 patient if you would like. But I've also seen people use up to about 1 million patients in terms of generating these data sets for a variety of reasons. Maybe you have an ETL that you're developing and you're anticipating a large number of records in that ETL. You can use a synthetic data set to kind of stress test your ETL, but there is flexibility in terms of the size of the population that you generate using Cynthia. You can also generate, different populations based on demographics. So, based on different genders, if you want, maybe you're a part of a women's center and you want to generate a population that's just based on females, you can do that. You can also generate age ranges of patients. So if you're from a pediatric organization, as an example, you can generate a pediatric patient population. Maybe you want to only generate adults, so 18 to 65, something like that. So there's a lot of options for how you could configure, demographics options within the Cynthia packages. You can also generate populations based on location. So say, for example, we're going to be using a population of patients from New Jersey today. You can also generate patients from a specific city as well, so Seattle, Washington, if you really want to get that granular. It's actually really nice in the way that you can configure the populations across the states. It is US-based, I should have said that. And then for different observation time or years of history, so you can generate, say, if you want, patients that have 10 years of follow-up, maybe 20 years, if you're hoping to generate like a long, longitudinal data set, you can also configure that as well. Not only can you configure things like demographics and size for the actual populations, you can also configure or add on what they call disease and intervention modules. So if you want to add, a specific population of patients with diabetes, you can do that. Asthma, cancer, they have these preset modules that you can choose from. But one of the cool things is you can actually make your own module. So if you have a particular very unique, patient population that follows their particular trajectory for their care, you can customize your own module to replicate patients that you would see in your institution and generate a patient population up to, any size that you would determine or any age and everything and like that. So it's really nice. Another thing is because it's going to be synthetic data, you're not going to have patient identifiers. So say, for example, you want to be able to share the data set that you're generating across, different institutions or different sites or with people, you're able to use Cynthia to do just that. And again, it supports many use cases. So again, we're going to be using it today for ETL development. As I mentioned, you can use it to stress test your ETL if you're developing, large data sets as well. It can also be used for data quality validation. So I know a lot of people in the room said they have already started, converting their data to the OMOP CDM. You can potentially inject some dirty data into the synthetic data set to catch certain scenarios that maybe you've already identified at your site that are data quality issues, things that you want to be checking on. So you can use it as kind of a way to do unit testing as well. And we can ultimately use it for tutorials like this one. All right, so to give you a sense of kind of the data elements that exist in Cynthia, because we can configure things like demographics, we see those variables right in the data set. So we have, age, specifically the date of birth for patients, the sex, race, ethnicity, and address information. What's also nice is that there's this level of social determinants of health also available in Cynthia as well. So if you're interested in doing some kind of like geocoding exercise, or you're interested in getting, particularly at the county level, information about like household income, things like that, that is already available in Cynthia as well if you wanted to do that kind of analysis or test out that kind of pipeline. There's also information on encounters. So the type of encounters we typically see in Cynthia are going to be like your ambulatory, outpatient, inpatient, emergency. So it really replicates like what you would see in the real world in terms of patient encounters with the healthcare system. You can see conditions and diagnoses as well, medications and immunizations, lab results and vital signs, and also procedures. All right, so as I mentioned, we would have sent out some links to you all. We do have the Cynthia tables exported to CSV. This is on our GitHub if you wanted to download them and take them along for the ride for the rest of the tutorial. But just to give you a sense of what is available, we have a relatively small data model, which is also nice. I know that if you're coming from an EHR background, there are maybe more tables than you need for your ETL oftentimes, but we have less than 20 tables in Cynthia that you can use to transform to the OMOP data model for this tutorial as well. The nice thing about it is they're also named, really nicely. So allergies contains data about allergies, conditions about conditions. So you don't really have to guess, what information is in which table. All right, so just an introduction into our population. So we have about 109 persons in our data set. They are from New Jersey, and about 61% of them, are female. You can see we have distributions of the year of birth at the very top. You can see that we have maybe a person that's born in 1926 or so. Maybe that's a data quality issue. We don't know. We can check later. But then we also see that we have the years of observation as a distribution as well. Again, we see that because we also set up the fact that we wanted 20 years of observation for this particular data source, we can see that replicated here. But we have quite a bit of time that we can observe people in this data source, which is really nice. Which you also maybe don't see in the real world. So again, just take it with caution that because we're configuring these populations, sometimes it might not replicate well in terms of what you see in your data at home. All right, so just to dive in a bit more, we're gonna look at conditions and procedures. So on the left here, we have the top 10 conditions. For whatever reason, we have 85% of persons with gingivitis and viral sinusitis. And then we also see some procedures as well, things that you would expect in terms of like physical examinations and things of that nature. One of the things I wanted to call out is that within this population, we have about 40 persons that have a condition record of normal pregnancy, which kind of tracks for the fact that we have about 61% of females in our data set, maybe not. But as we start to think about, potential data quality or, start to think about the expectations that we have for a data set based on population, we might want to look at these type of things for distributions to say, okay, am I seeing records that I would expect? Cynthia is also nice because if you think about, 40% of persons having a code for normal pregnancy, you can see things and procedures that kind of align with that patient population, having things like ultrasounds and assessments and things like that. So it's fairly nice in terms of replicating these real world scenarios that you would expect. If we take a look at drugs, we can see this is a heavily vaccinated population, potentially more vaccinated than the general population. But we do see some records in there that we can use for the ETL. And then we also see that there are quite a bit of labs that are, appearing for our population. 100% of patients have platelets, hemoglobins. Maybe not what we would expect in a general population as well. And in some ways, Cynthia can tend to be a little bit more rich than what we would see for the general population. But we do have these kind of records that we can use to, at least observe what could happen with drug mappings and lab mappings. All right, so how are we doing on time? I think I probably caught up a little bit, but I guess how are we feeling? Do we want to take a break? Do we want to keep going? All right, raise your hands if you feel like you need to end a break, get out of your life. One person. All right, let's do that. All right, we can do it. Love ETL. All right. Okay, so we've talked about the vocabulary, we've talked about the OMOP CDM, we are now experts in our data and we've met our patients. Now we can talk about the ETL process. All right, so we've gathered all of us in this room. Again, we are the data experts. We are now experts in the CDM. We have Pusheen Cat and also a friend eating, I guess, chips and dip. We're now together to talk about the ETL. That's really the first step in the process. So it's really a meeting of the minds to help us understand we have all the people in the room that'll allow us to have the most successful transformation for our CDM. Just because we know our data the best, we know how we intend to map it to the OMOP CDM. And there's also tools available in Odyssey to help you do that. So one tool is called White Rabbit, which is essentially what we'll walk through today as well, that allows you to scan the data that you have at your source. So that'll give you a high-level view of the tables and fields within your data set. It'll also give you some frequency counts of the values that you see appearing in your data set as well, that you can then use in another tool called Rabbit in a Hat that allows you to write ETL documentation. So literally, we're going to be going from one field in the native to maybe more than one field in the CDM, but we're able to essentially use these two tools to get a sense of what exactly is in our CDM and how we're going to transform them. From there, because we've talked a lot about vocabulary mappings and the fact that maybe there are codes in our native data set that do not map directly to the OMOP CDM, we often will need to get together with experts. In some cases, you might need to meet with a clinician at your site if you're from a hospital, or someone else who has some kind of medical knowledge to assist you in this process. And we also have tools, one called Usagi, that we won't be demoing today in its traditional form, but Max will also show a new version that I'm really excited that he's gonna walk you through today. That'll show you how you can also map those non-standard codes or unique codes at your site. From there, now that you have your mappings ready to go, we have that ETL document written, we know exactly what's happening in our data, we can now turn that ETL documentation into a place where we can essentially hand that over to a developer, or if you are the person who is also writing the ETL documentation and also developing the ETL, you are no stranger. Sometimes those two people are one and the same. But now we have essentially a long document that we can use to now go in and code the transformation that we want to have on our CDM. I will say, we also want to implement some data quality measures as well. So Maxim will also run through some tools that we have in Odyssey, DQD, and Achilles that help us to understand how well our data is conforming to the CDM, help us identify any unexpected data quality issues that we might have observed or remediated at the time of our ETL. And from there, it's really an iterative process. I will say I haven't come across an ETL that we've said, oh, it's one and done. I'm never going to update this again. It's totally perfect. Oftentimes because we have, data that's changing, right? We're updating our data maybe daily, maybe monthly, quarterly. Things change that could, potentially change our assumptions about our data as well. We have the vocabulary updates that we've talked about already that we would have to consider. Maybe there's codes that were, previously unmapped in our data that we can now map because there's actually a vocabulary to represent them. But there's oftentimes we discover maybe bugs or people are using our data and have questions about maybe things that we can fix or maybe things that we can map better. So it's really an iterative process for the ETL process, and it's actually one I enjoy, and it keeps on going. All right. So with that being said, we do have some resources available. So there is the Book of Odyssey. There's an entire chapter devoted to ETL that you can go and read. But again, the conversation keeps going. I know that Karthik talked about the working groups that you can join. It's really good to join those CDM working groups or the Themis working groups for like-minded people to really ask questions. Oftentimes, we can get together and develop those standards about how best to map our data. If you have questions about how to map your data, there are people that you can also reach out to. I guarantee you maybe someone else had a similar question, if not the same question, going through the journey. So please feel free to reach out as well. Okay, so I promise we are going to dig in, and you can also follow along if you would like. So we are going to scan our database of our Cynthia patients using White Rabbit. We're also going to practice building an ETL document using Rabbit in a Hat, and Claire will walk through that. And then, as I mentioned, Maxim will take us on a journey to also use Achilles and data quality to take a look at things that we see and observe in our data. All right, and we are going to go to live demo. And I guess, do we have it up in the background?
Yeah, it's up here. Find it.
Ooh,
All right. Let's see. See, is it this one? Nope.
the other one.
There we go.
Okay, great. Alrighty. All right, can you all see that okay? Do you need to make it a little bigger? Thumbs up, thumbs down?
Hard to make I don't know how to make the text.
Let's
That's the
see.
problem.
I think that's all we got. Okay, I will try to walk through it best we can. All right, so this is the White Rabbit tool. When you run the program, this is the screen that you'll see open. Just to orient you a bit, there are a couple of things going on. So the first tab that you will land on will be the Locations tab. And one of the first things you want to do is essentially pick a folder, which will be the option to the right. Now, you can set this to be your desktop or a folder that you will remember. This is essentially where the scan report you'll be generating will live. So you might want to put it in your desktop or maybe in a folder called, My Amazing ETL, if you would like. From there, you would want to specify the source data location. For this tutorial, we're going to be using a Postgres database. That's where Clair has the Cynthia data loaded, so we can access that. But there are quite a bit of options in terms of what you can connect White Rabbit to. You can use delimited text files, so CSV files if you would like. You would also specify the delimiter right at the bottom if it's going to be tab separated or comma separated. But there are a variety of databases supported. Oftentimes it aligns with the databases that are supported by Odyssey, so the Hades suite. So if you have SQL Server, MySQL as well, Oracle, there's even Databricks as well. From there, you can specify the server location, username, password, and database name. I did want to mention that if you were to go to the White Rabbit GitHub IO page, for your particular DBMS, they have this information specified. So they will tell you exactly what you would need to put in for your server location and username, password, database name, how it should be specified. I know there's a little bit of differences between schemas and databases based on like Databricks and Postgres. So they have that guidance there for you to also use. All right. So once you have the location set up, I will say you would want to test your connection. Always good to test your connection. And this lets us know that we successfully accessed the Postgres database, so that's good. We're all connected in the right way. The next tab that you'll go to is going to be called the Scan tab. So I'll do a couple of things here. Just when you actually access this tab, the scan box will be empty. So you can do a couple of things. You can add all the tables in your database at your own risk. So if you have a fairly large database, you might not want to start and do that. As I mentioned, the Cynthia database is about less than 20 tables, so we can pull those in. You might not need all the tables that exist in your database for your ETL. Like thinking about some of the EHR backends, there are a lot of lookup tables, there are a lot of like transaction tables. Maybe you don't need those. Maybe you just need like your patient table or your condition table, whatever it may be called. But for the purposes of today, we can just add all of them in. There are the add and remove buttons if you wanted to kind of select all the tables in a one-by-one fashion and add or remove them. All right, so down in the middle pane or so, there are some additional options that you can also select. So this first one here is called Scan Field Values. So White Rabbit has the option to scan your tables, of course, to say what tables and fields you have. Using this Scan Field Values would allow it to essentially look at the values within each of those fields to be able to generate the summaries and frequencies that you want. It really depends on if you want to do that. For the purposes of today, we will, just to get a sense of the values that are in the fields within our tables. There's also another selection here called Min Cell Count. By default, it's set to 5. If you think about, privacy preserving, oftentimes min cell count would be 10 or 5. That will allow you to share data with another organization, essentially saying that you preserved privacy by having a min cell count. For today, because our data set is so small, we're actually going to make that 0 just so we can see all the available values within the data set. There's another option called Max Distinct Values. So again, White Rabbit has the option to look at the Cynthia tables And then essentially you can set these parameters for how many distinct values you want to display within a particular field. It can go up to 100,000. Depending on the field, you might have that many unique values. But if you can imagine a field like gender, it may not even have that many unique values. Things like units could, depending on typos and things of that nature. So you might want to see all the available distinct values there. There's also an option to specify the rows per table that can go from 100,000 all the way up to all the rows in a table. Now, depending on how big your data is, you might not want to scan all the rows in the table, just in case the queries are going to be hanging for a long time. I'm not sure if you might get in trouble from your DBA for long-running queries. But for today, we'll just stick to 100,000, but there is the option to kind of set those limits there. There's also these additional options for numeric stats. So for a field that is potentially like an integer, or maybe you have like a particular lab value field that is going to be a number, you can check this button and it'll allow you to see some numeric stats. So like means, standard deviations, things like that. We won't do that today. All right, so from there, after we set all our parameters and we have all of our tables to scan, we can click the Scan Table button. As you can see, we did this a bit earlier, so we, just cheated a little bit to make sure that it will actually work for today's demo, but it is running there. The nice thing is, though, it'll allow you to see, as it's running, what's happening. So as I mentioned, it scanned about 18 tables, and if it gets to a table that is too large, that it had to essentially stop at that 100,000, it'll let you know. So in this case, that was the claims transactions table that it had to stop at because it's much larger than 100,000 rows. All right, so I put that scan report on the desktop so we can take a look at it. Let's make this a bit bigger if I can. Yeah. Ah. All right, how's that?
Can I ask a question while you're doing that?
Yep.
Can I just talk louder?
It's for the video, not it's for people in the room, but it's for the
Okay.
video.
So in the realm of real world data, 100,000 rows is not a lot.
Yes.
So can you just talk about how do you scale to a real scenario?
Yeah, it's a great question. So the options here can go from 100,000 as the start to all, as I mentioned, or 1 million rows. So you can configure it that way. We typically, it depends, but we typically would take that sample as mostly representative, just depending on the frequency of the values themselves. So you would say units is tricky because there's always going to be some misspellings, but if you have like inches, you're usually going to see like high frequency of those values pretty often.
So is it, feel free to repeat it. Is it a random sample or is it top 1,000?
Do you remember, Maxim?
Yeah, it depends on the...
Depends on the database. I know for Postgres it's implemented as the top so many rows. Because SQL Server is actually a random subset.
Yeah.
A tip for Postgres users, there is a nice feature in Postgres to say, give me a sample of. So you could also first subset your table and run White-Rabbit on that. Might also warrant a feature request for White-Rabbit.
Yeah.
And really what we're trying to get at here with the scan report is we really want to know the structure of the native data because this scan is going to feed into our rabbit in a hat kind of GUI interface. So we're trying to get that high-level structure as well as maybe start to identify some of those pieces we want to think about from a data quality perspective. So like she was saying, I try to run White-Rabbit against our major databases at Johnson & Johnson, like the 100 million person databases, and I do get yelled at, and my queries get canceled because they're like, this is taking too long, whatever. So it is a balance, but the idea really is hopefully your 100,000 person sample should, or 100,000 row sample should at least give a pretty good idea of what's in the database, enough that you can start to build your ETL, and that's why the ETL is also an iterative process, because we don't expect we would find every single thing we need to address on the first pass.
I fact-checked myself, and Postgres is random, but it's implemented very inefficiently for large tables with order by random. So still, subsetting might be more feasible, depending on your table size. Yeah.
Right. Yeah, so again, I would say, for these scans, it's really meant to be that first look at your data set to help you understand what's going on, what you could potentially see. For more deeper dives into particular fields, you would want to, run your own queries and whatnot. But just to get started, we typically use this to get a sense of, what this database looks like in terms of its shape and what's going on. All right, so when you generate a scan report, you have a few different tabs. So you will have a field overview tab, a table overview tab, and then for each of the tables in the database that you specify, you'll have a corresponding tab as well. So the tables tab essentially just gives you the names of the tables that you would have, the number of rows within that table itself, and then the number of rows checked. It'll also give you the number of fields and the number of fields that are empty. So again, to your point, in terms of understanding how well this particular tool is covering the amount of records in your database, you would say, okay, so I know that this, because it's a fairly small data set, my scan actually covered all of the rows or all the records in the allergies table. So I can be fairly certain that it actually looked across the entire table to understand what's going on. But again, we know for the claims transactions table, it is larger than that 100 patient or 100 row sample that we set up. So we know that it's not necessarily covering all of the tables. So proceed with caution, but we could be getting, a pretty decent representative sample of that table as well from the scan. All right, if we jump back to the Fields tab, you can also see the table name the table name to the left here, the fields within that table as well. I'm usually very interested in understanding the types associated with particular fields, especially if I'm doing an ETL and need to do some conversions as well. You can see the length associated with those fields. Again, the number of rows and the number of rows that were checked as well. You can also see the number of unique values and some stats there. All right, I actually want to jump to the patients table. There is a lot going on. Oh, sorry, Claire, I am not doing well with the mouse. All right.
Got some scam text about click one.
That's all right. Okay, scroll up. All right, so I've opened up the patients table here. And what I'd like to make sure we understand is that, we have a column for each field in the table itself, and then we have a frequency column that's also associated just with this particular field. So how you would interpret this is that you have an ID field, and these are the unique values, up to the number of distinct values that you specified, and you also have a frequency associated with that. So I can see that this particular ID appears one time in this patient's table. You can imagine if you have a patient's table that you think should represent like one row per patient, and you get maybe some IDs that have duplicates, then you potentially know you have an issue with this table and need to understand like what exactly is happening. So this lets me know, at least for our patient table, we have unique persons. Now, if you also look at the birth date column, you can see that there are the unique date values that we see in the data as well, and we also have frequency values. Now, you wouldn't interpret this as, this ID is associated with this birth date, and there's three. Essentially, what you want to be able to say is, for this birth date field, here are the unique values, and this is the frequency. So we see 3 persons with this June 5th, 1949 birth date within our patients table. Same thing for death. We can see that we have 100 null death dates, so persons who are still alive, and then we can see the individual death dates associated with persons who have that populated. And it really goes on like that in terms of, having social security numbers in here. There's also driver's license numbers, first names, last names, all of that exists. All right. Maybe jumping to our conditions table. We can also take a look at a few things. So taking a look at the conditions table, we can see that we have start and stop dates. We do see that, we have, unique start dates as well, and some that have conditions starting on the same date. We do see that quite a bit of records in this table do not have a stop date or end date, but teaser for the condition occurrence table, that is not a problem. We also see that we have system associated with these conditions within the actual condition table. We can see that the majority of them are going to be SNOMED CT codes, and we have some ICD-10 codes coming in as well. So this lets us know, okay, I'm looking at my data, I have some SNOMED CT codes, I know that the OHDSI vocabulary supports SNOMED CT, so I know that I'll be able to map my conditions that are in this table to potentially the condition occurrence table or observation table. There's also ICD-10 codes, again, another vocabulary that's available within the OMOP vocabulary, so I know I'll be able to map as well. You'll also be able to see that we have some descriptions, so we have source values that we can see and be able to use as well. Again, you can see those things popping up like gingivitis and things that we saw when we started to take a look at our population. All right, and last but not least, I'll jump to the drugs table. That is probably this way. Medications. All right. So looking at our medications table, it looks kind of similar to the, oh, go ahead.
How are condition stop dates defined?
In Cynthia.
Oh, okay, but I mean, like, I guess thinking beyond a synthetic data set, is that typical to have condition stop dates?
Not typically, especially in EHR data, you don't necessarily see, unless you're thinking about something like oncology where you have remission that has potentially a stop date. I've also seen maybe start and stop dates in like problem list types of encounters where you might have, those type of things, but typically we don't see an end date.
I was just surprised at how complete that column was.
Yeah.
But that makes more sense.
Yeah.
Okay.
All right. What I did want to show you, though, is for medications, it actually looks pretty similar to conditions. However, we would expect more medications to potentially have an end date, because when you're writing a prescription, you would say, maybe 6 months supply or something like that. So this is potentially a data quality issue that we can observe in Cynthia. But just to give you a sense of, what you can use the scan report for, you can see that you can, generate frequencies and understand what's going on in the data. You can start to clue in to potential data quality issues. If you see dates that are out of whack or you see fields that are missing that have a lot of null values, you can start to ask questions and start to think about how you would approach that at the time of writing your ETL. Or, have a sanity check for, am I preserving some of these things when I go to run the data quality dashboard, as an example? Am I seeing what is true to the data, potentially, what I observed in the initial scan report as well? All right. And then from there, I can turn it over to Claire to jump into how we would now write our ETL document.
Yeah, super fun. Okay. How are you guys doing break-wise? This is a good stopping point. I wasn't going to take you farther than 3 o'clock without a break. How's that sound for everybody? Okay. So we've talked a little bit about the resources that are available. I just want to show you where they are in case you want to know. Please don't judge my million tabs. I am a tab hoarder, so just disregard all the stuff to the left. All right. So the first one we talked about was Athena. So athena.odyssey.org. So this is where you can search the vocabulary, but also download the vocabulary. So this is a really good one. I may ask for some help for searching the vocabulary later on, and this is where you would go to do that. All right. So then we've also talked a lot about the GitHub. So let's see. Let's see if I can remember it off the top of my head. github.com/odyssey/tutorial ETL. So github.com/odyssey/tutorial ETL. So this is our GitHub repository with all of the materials we are using today, including, thanks to Evanette, our slides. I did forget to put them up there, but Evanette saved me. This link is also in the email that was sent out, so you should have this as well. But if you wanted, here's our PowerPoint we're using today, and then we've also got our data in here with this raw Cynthia data, as well as the transformed version of the data sitting here. So in case you needed that. We also talked about, now I gotta go to the IO page. Let's see, odyssey.github.io. You can tell how much I go to these sites. All right, so odyssey.github.io/common data model will take you to our CDM homepage. You see some information here about the working group. What I really want to point you to is under CDM versions. If you go to CDM version 5.4, and we click here, there's all the detailed information about every table and every field. So this is a really useful resource. And the last one I'm going to quick point out to you is Themis that I did. Why is it doing that? Let's see. Is it not, there we go. Do not all caps rage it because it will not work. So it's just a capital T. So this is the Themis repository that has all of our general conventions for how to map your data into the CDM. This is really helpful for when you have a question about what do I do in X scenario. This is where those answers will live, and they do live. This is evolving though, so if you post a question on this Themis GitHub, you just click right here, it takes you right to it. And let's see, Melanie is really good about keeping this updated. So you can see there's some questions here, like Karthik was talking about microbiology data, and here's an open question right here about how are we mapping microbiology data. So just wanted to quick stop and pause and make sure you guys have those resources if you would like them. All right. So let's go ahead, hopefully it's the right one. Miscalculated. All right, so let's go ahead and jump into Rabbit in a Hat. Let me just double check I'm not missing any slides with super helpful information that you guys need. All right, I don't think so. All right. Yeah, so like we mentioned, Rabbit in a Hat is a nice user interface that is going to help us map our native Cynthia data that we just talked about and we just scanned over to the OMOP CDM. Like I just showed you, the materials are available. So if you wanted to just grab the scan report instead of the data, it's available for you there. Let's see, is that the right one? Ah, yes. And I need to reload the scan report I already have because I realized I ran it with a min cell count of 5 instead of 0. So we were going to be missing some information. We're going to replace the current data. All right. So like we talked about, when I approach an ETL, and I'm going to come at this, I'm going to walk you guys through it how I typically do it, because this is just like the thought process that I have as I approach a new ETL. The first thing I'm going to do is start with the person table. So as we talked about earlier, the person table is one of the most important tables in the CDM. If you look it up actually on our website, there's only 3 required tables in the CDM: person, observation period, and CDM source. You could technically have a CDM with just those 3 tables. The reason those are the only 3 tables that are required is because everybody's native data looks a little bit different. So if we said you have to have conditions, you have to have observations, it might not make sense for someone's data to actually have those tables populated. But really, to have a CDM, you have to have person. We need to know when they're observed. And then for CDM source, we need to be able to identify your data source. So when you contribute to network research, we know who you are and what your data is. All right, so we're going to start with person. I'm going to drag this guy up. So here we are in Rabbit in a Hat, and you saw I opened up the scan report, and I pointed to the one we just created, and it actually populates all these orange boxes. And the purpley boxes here, these are all the tables in the CDM itself. So the really nice thing we can do, and I like to make it pretty, so I like to drag my tables so that they're across from each other. The really nice thing you can do is you can just hover here. We already talked about the patients table in Cynthia, so I can draw a nice little line over here to the person table, and I know that when I start to write my code to take the native data over to the CDM, I'm going to be taking the patients table over to the person table. So if you double click on the arrow, it's going to bring us up another table or another visual here, where now the orange is, these are the set of columns in my native data. So these are all the columns available in the patients table, and here are all the columns available in the CDM table. What's really nice, and the reason we actually pull in the scan report, is because when you click on each of these boxes, it shows you what's in the scan report for that column, and that can be really helpful. So it is nice to go through and make sure you are looking at your scan report, evaluating it, that sort of thing, but it is also helpful here to then be able to see exactly for each column what was scanned, what the frequencies are, and that gives you a really nice idea as to how you can start mapping your data. The other nice thing is it's going to tell you a little bit about the CDM fields as well. So here we can see we've got our person ID, and we've got a couple different columns here that have the asterisks. Now in typical I don't know, like online web form fashion, you know, we all have to fill out. Anything with an asterisk means it is a required field. And then we've got a nice little description here. All right, so we've got our ID here from the Cynthia table, and we've got our person ID. But I immediately notice a little issue here. The person ID is an integer, and my ID in Cynthia is alphanumeric. Now, one thing we've talked a little bit about, and I really want to reiterate, is all of the source values, all of your source data are represented in the CDM alongside their standardized version. So a lot of times we hear concerns from people who are newer to the process saying, well, if I map to standard concepts, I don't know what the original maybe ICD-10 code was, or how do I know what was in my source data? All of your source data is still represented in your CDM. They sit side by side, they're best friends. We just use the standardized version to help us generate evidence together in a standardized fashion. Because then once you have those standardized versions, you can start to use open source software, you can start to run patient level prediction models, you can start to do causal inference, all using the OHDSI tools and methods that have been built on top of the CDM. So that's really where the power, like one of the reasons data standardization is so powerful. And it all starts with the person ID. So knowing that we have our alphanumeric here, what we can do is actually take this ID, and like I said, we keep all of this source data. So we're gonna map the ID field over to person source value. And what we can also do is we can take a little arrow here and map the ID field to the person ID. But we're going to add a little note in here for ourselves. And we're going to say, create a new numeric ID for each unique ID from the source data. Something like that, just so we know what we're doing here. And what's going to happen is at the end, once we generate our document using Rabbit in a Hat, all of these notes, this logic, and any comments you have here, those will all be outputted into your document. So it's a really nice way to just kind of go through each different field, how you want to map it, and at the end, you can export a really nice document. All right, so let's go into the next one here. All right, so here's another little difference between Cynthia and the CDM. Cynthia gives us a birth date, but in the CDM, we have birth date split out into year, month, and day. And if you'll notice, year is the only one that is required. Now, anybody have an idea as to why we do that? Yeah? Yeah, anonymized privacy, yep. Also, the other thing is, most of us don't get a full birth date in our data. A lot of times all we get is year of birth because of patient privacy. So even if you have it, you may not even want to put it in. You know, if you're participating in network research, you may not want to allow that PII or PHI into your CDM at all. So what we can do here is we can map our birth date to our year of birth, just like we did with person. And we can write logic in here, extract year of birth from birth date. And if you wanted to, you know, you could map month of birth and day of birth, but again, you can see they're not required, so it's totally up to you how you want to handle that information in your own ETL. All right. So let's see. I'm going to scoot down. Let's see. The next thing we have that is required is race and ethnicity. and gender. So I'm going to start with gender here. And here are all the options available to us in the CDM. But first, let's find gender for Cynthia. Here we go. Okay. So what we're going to do is we see here in Cynthia, we've got this M and F, male and female, pretty standard. A lot of our databases look like this. But a lot of my databases, I don't know about you guys, I often get like a blank or a U. This is where Cynthia is super clean because we have 66 people with an F and 43 people with M, but we have nothing messy in here. But for me, at least, I typically see some additional values in this field that don't quite make sense or don't really map to anything. So in that case, if I have something that is not a true sex at birth, and it's blank or I don't know what it is for a person, in my databases, I actually remove those people. Because I think of the CDM as I think of it as like an analytic layer sitting on top of, or maybe not on top of, but beside my native data. So I can always go back to my native data if I need to and look again and see, oh, well, I removed this person who didn't have a gender. Maybe in a later iteration of that database, that person does have a valid gender, and we can come back and rework that. But this again is this is kind of a site-specific decision for you guys and how you want to do it. It's kind of the same thing with birth year as well. We get people who have odd birth years, like Evanette mentioned there was one with 1926 here. That might be odd. Usually we really see stuff like 1850. So if I see someone with a birth year of 1850, I kick them out of my CDM because I am not convinced that's their true birth year. So it's just something to think about as you go through, really on the person table specifically. So Maxim's going to go through this in a little bit, but in my databases at J&J that Evanette and Erica and myself work on, we remove people who have unknown or a sex at birth that we cannot determine from the data, and we remove people who have invalid years of birth, and then we also remove people who have records that occur prior to their year of birth. So if we see a year of birth of, say, 2006, and they have records in the data going back to the year 2000, we actually remove that person because we are not confident that the person's data is actually being represented faithfully to them as an individual. So just as a thought, just that's what I typically do or what we typically do, but everybody is a little bit different. So just keep that in mind as you're going through your ETL, what you want it to represent. And for me and our team at J&J, it is our clean layer of data. So we try to remove those things that if a researcher was not aware of them, that it could become a problem for them down the line. Like Karthik was saying, a lot of people just go run something on the CDM and assume everything is perfect. And so just keep that in mind as you're building your ETL. All right, so I'm gonna quick go through gender here. So like I said, we keep everything in our source value field. So first what I'm gonna do is I'm gonna map gender, my M and F, to our gender source value. I map the verbatim values over to gender source value. And then I'm also gonna map to gender concept ID. Now the concepts in the person table, they're a little bit different than what we're going to encounter with like conditions and drugs. So in the person table, there's not really a need to run a query to say map some standard or some source vocabulary to a standard vocabulary. Usually in this case, you have, in the case of gender, you have two values. The nice thing about rabbit in a hat is that it shows you what those potential values could be based on the vocabulary. So what it does, it actually is pulling up the vocabulary for you. It's giving you everything that could potentially be used as a standard concept ID for gender. In this case, we only have two. We have male and female. Female is 8532, male is 8507. So instead of writing a query, what I typically do for gender is I just say set M to 8507, set F to 8532. Now later on we'll get into some of those queries and how you do those like automatic mappings using the vocabulary. All right. Now a really good example for Themis and a question we've gotten in the past is what about patients who what about questions of gender identity? So in the CDM, we are specifically capturing a person's sex at birth, but there are instances where we might observe someone's gender identity. And so there have been some questions about, well, how do we standardize that data? How do we map that data? So this is an example of a convention that is nicely documented in Themis. So I went to the Themis Convention Library, and here under gender identity, the main question is how should gender identity be stored in the CDM? There's some links to a discussion. And so really here under ratified convention, we say any gender-related information that can change over time, like gender identity, not necessarily that it does, but it could, that should be put in the observation table. So if you had a question about that, this is a great resource and a great example of how you could use the Themis Convention Library while you're walking through your ETL. All right, we're back. So I'm not going to go through race and ethnicity. They're pretty similar to gender. There's just some more concepts available, some more additional standard concepts for race and ethnicity that are available. So in this case too, right now ethnicity is really representing the US definition of ethnicity, and we know as a global community this is not necessarily how everyone in the world thinks of ethnicity. So actually Melanie Flosky, I know I've been talking about her a lot, she has I think a poster, and I know she's actually going to be presenting at a LOINC conference, so she's leaving Odyssey early to go present at LOINC about how we need better standards for race and ethnicity. So if you have questions about that, she is the one to talk to, and I know they're working on this in Themis as well. So you know, really this is very similar to gender, where you look at the text value you have, you find the best related standard concept, and you can either map them by hand. I think we have some different examples of how we do this, and I'll share with you our J&J ETL documentation where you can see some different examples of how we do this. One thing I will note, so like Karthik talked about, every standard concept ID, for the most part, there's just a couple that for this, where this doesn't apply, every standard concept ID has an associated source concept ID. Now, typically the source concept ID is what we use to map to the standard. So in the case of condition source concept ID, you know, and I'll show you this in a minute, you find your concept ID that represents your, say, ICD-10 code, that becomes your source concept ID. You then look up that source concept ID in the vocabulary and which standard concept ID it then maps to. It'll make a little bit more sense when I can actually run through it. But in reality, we also have a gender source concept ID here. Most of the time, I don't know that I've seen very many source terminologies that represent gender. In my case, I like to put a 0 here just to say, hey, set this to 0. You can leave it as null, but null sometimes they're sneaky and sometimes they hide. So Maxim and I and Katie Sadowski, if you've seen her, she is the one who is doing a fantastic job maintaining and updating the data quality dashboard package. We recently found a bug where there were like nulls that were hiding in a data quality check, and we weren't adequately evaluating the data quality check like we thought because the nulls were not being, they weren't coming through in our query. So Erica used to always harp on about this, how we always need to set our concept IDs. If there is none, set it to 0. And then it came up, actually came up in a real example where we were like, oh no, this data quality check is not doing what we thought it was because the nulls are putting a wrench into our system. So just keep that in mind. I feel like there was an ETL tutorial we did like years ago at the European Symposium, and there was a person who was arguing about nulls, and we were like, yeah, man, it's your data. Do whatever you want, but we've just been burned too many times, so we put 0. Yeah, I would put 0 personally. There is an argument that technically in the OMOP vocabulary, a 0 concept ID means no matching concept. Yes, exactly. So if you're being faithful to the definition of 0, in this case, it may not technically be true. And so, the argument we had a few years ago, this person was saying, well, if there is no value, say you have a measurement and there is no unit associated with that measurement, but we still put a 0 in the source concept ID, the person was saying, well, in that case, you should put a null because a null technically means nothing, there is no value. And so that's a strict DBA definition, that person was right. But we have seen problems in the past where nulls can be sneaky and hide depending on your DBMS and your query. So just, use your best judgment here. Our best practice is to put zeros in places where there is no concept to be had, just because it makes our lives easier down the road.
I might have been that person, Claire. Still, I agree here to set it to 0.
Yeah.
Source
It wasn't
value.
you, it was another person.
Someone
but-
else, but I still agree.
Yeah.
There are also values where you might not have something like a value concept ID in a measurement table. If you set that to 0, actually the quality reporting will report that your mapping is incomplete because you are having zeros in there. Well, you say, oh, we actually didn't map to it. That's a use case.
Yeah.
And in the vocabulary tables itself, 0 sometimes also encodes something.
Yeah, the
What about
word
null?
null, sometimes the word null can be an actual value to an answer. So now that we have more surveys, so there are exceptions to this rule, absolutely. This is probably like a 90-10 rule, but it did recently burn us in a data quality dashboard query. So I thought I would just bring it up because it's been a consistent question. Yeah, there's a question in the back.
What do you think about where, like, for example, in this case, in the person table, where, like, for the gender source concept ID, like, filling that with the concept ID for that gender? What do you think about that?
So putting the standard concept there, you absolutely could do that. Like, that's not a problem. Where I would caution against, like in this case, there is no source vocabulary for the gender,
Right.
so that is a perfectly fine choice. Like, that is not a problem. I wouldn't do that in other cases, like in the condition table or the drug exposure table. I would use the actual source concept ID. But in cases where you don't have one, you absolutely could use the standard. We have done like something in the past, I think, too, when you're doing manual mappings, where you could put that standard concept in the source concept ID field with that manual mapping, just to indicate perhaps that it was a manual mapping. Like, that's also fine.
Okay, thank you.
Yeah. All right. So let's move on. I want to make sure I hit all my points here. All right. So let's move on to observation period. Let's see. It's 2:55. I told you I would let you have a break at 3. So let's move on to observation period, and we'll kind of go from there. All right, so as Karthik said, the observation period is one of the most important tables in the CDM, but it can be one of the most frustrating to populate. In certain data sources, like he was saying, like in administrative claims, the observation period is really the time a person is enrolled in a health plan. Now, the way we define observation period in Odyssey is that it's the length of time during which I'm relatively confident if a person had an encounter, it would be recorded. Now, that's a pretty ambiguous definition, and it doesn't give concrete, here is how you put it together, and that's because this is one of the tables that is very site-specific or specific to your data. Now, what we typically do with something like, I think of encounter data, or the person doesn't have an enrollment in a health plan necessarily, the way that their interactions with the health system are recorded is because that person goes to some physical location. So like, I think of a hospital electronic health record as encounter data because the person is physically going to that location, whereas something like administrative claims I think of as enrollment data because a person is enrolled in a health plan in any building they go to where they are getting health services. Those health services are being captured under that enrollment in the health plan. If you have both, which supersedes the other? That's a really good question. That's a tough one. Personally, I like to be more conservative and hang it on the enrollment. We have a data source. So I'm thinking of a data source where there's administrative claims linked to electronic health records, right? In my particular case, in the work we do at Johnson & Johnson, we are in drug safety specifically. So when we think about, when we are evaluating outcomes related to our drug products, we have to be very confident that any outcome the patient experienced is being observed in the data. So I have to be very conservative with our definitions of the observation period. So in the case, I do actually have a data source like you're talking about, and I limit to the enrollment period. Now, there are other people in our same organization who did not want that limitation. They actually wrote an entire separate ETL where they only changed the observation period because they wanted to bring in all encounters for patients because they did not have the same safety remit that me and my colleagues have. So a lot of it may come down to your specific use cases as well. But that's a really great question. Now, what we've done in the past for electronic health records, and I think of Cynthia as electronic health records or encounter data. What we've done in the past is say you can take their first encounter as their observation period start date and their last encounter in the data as their observation period end date. That's what we've done for Cynthia, but there are some other more conservative options for electronic health records as well. But here, actually, I'm not going to start these arrows moving because we're about at 3 o'clock. So let's take our break. Does 15 minutes sound good for everybody? All right, let's take our break now. When we come back, we'll dive into this. Please come back at 3:15, and we'll get going into observation period, condition, and drug exposure. All right. I think everybody is back now. Thank you so much for adhering to our 15-minute timeline. Let's see here. All right, they're pasting up an entity relationship diagram. If you guys are data nerds like us, we have a really fun entity relationship diagram for the OMOP CDM that Renska, who couldn't be here today, helped to design along with Martijn Schumi. And it's very fun.
We have an anthem.
Well, we do need an anthem.
We have one with notice the Lego song, right?
The Lego song. Yeah. All right, so let's dive back into the observation period. So there was a really good question by Charlotte. Thank you, Charlotte. And she was asking about, if I have I don't have every visit for a patient, but they come to me occasionally when they start up treatment again. So for example, Charlotte has cancer registry data, and so she doesn't see every single thing that happens to a patient, but she sees the things that happen when they are entering the registry and when they are interacting with the registry. So I wanted, and Maxim had a really great response, and I fully agree with this, is that the observation period is context dependent, meaning that you don't have to be able to observe every single thing that happens to a person, but the observation period should represent the span of time that if that person were to interact with your healthcare system, your registry, their health plan, if they were to interact with one of those entities, that it would be recorded, that it would be covered under that observation period, if that makes sense. So in the example of a hospital EHR, for me, maybe I only go to the hospital 3 times in my life, but really every time I go to that hospital, as long as my encounters are recorded, though that is my observation period, because that is what the hospital has for me as a patient. They're not going to see all the times I go to the urgent care for viral sinusitis, as we saw earlier, but that's okay. It is not an expectation that your database should be fully complete for every patient. It should be complete, though, based on what information you should have on every patient. Does that make sense? Okay. Another really conservative approach that I don't usually employ, but it is one we have kind of batted about, is if you wanted to be super conservative, say again you have a hospital inpatient electronic health records, you could set the observation period just to the time that the person is actually in the hospital. So you could set individual observation periods for those spans of time that they're being treated as an inpatient. But again, that does make it a little challenging to do additional longitudinal research, because we expect both your, say, exposure and outcome to happen within one observation period. So in that case, you would be limited to the exposures and outcomes within that one hospital encounter. So there are different options, and really you should think of it in relation to what kind of data you have, what data for the patients in your kind of database, what data are being represented, and how would you expect that patient to interact with your, I'm going to say health system, but interact with your entity that is generating the data that you are now mapping. And I'm being very generic here because there's a lot of different ways that you might be getting data for your patients. All right, so let's go here. Again, we have ID. So this is actually the ID for the encounter, but we also have the patient ID. So I like to start, now I've created my person table. I'm going to make sure I start with my person. So I'm gonna map patient to person ID. And again, we put this patient alphanumeric in the person source value. So in my little logic, my notes to myself, I'm gonna say map patient to person source value and look up their person ID. So very simple little instructions for yourself. All right. We also have another ID representing just the observation period ID, like Karthik was saying earlier. These are just primary keys, like unique numbers to help identify each record in the table. Usually in these cases, in the comments, I just say like, generate a random ID. Like we have like a auto-generate function that just creates the IDs. All right, now in this case for Cynthia, I'm gonna take the approach that the first time I see the patient in my database, that is their observation period start, and the last time I see them in the database is their observation period end. So that is what I'm gonna do here. So I'm gonna map start to observation period start date and stop to observation period end date. And so what I'll say is there, because this is encounters, people probably have multiple encounters in this database. So I'm gonna say take the earliest stop date, we're on start date for each patient as their observation period start date. And then we'll do the same or similar here. Take the latest stop date as the observation period end date. Okay, pretty straightforward. And then the last thing we need to do is we need to choose a type concept ID. Type concepts are meant to represent the provenance of the observation period, really the provenance of the data. So we think of that as like, in this case, I think of Cynthia as electronic health record data, so I would choose EHR. Maybe you have a registry where you get information from case report forms, so you can choose that here. Or maybe you have claims, and there's some other options down here as well. So really, this is a helpful information, especially like in the case if you have multiple data feeds coming into one database. It can be really nice to use your type concept IDs to delineate between them. But in this case, we're going to call it EHR, and I'm going to say set to 32817. So this is another concept ID where we use the standard concepts and we just kind of manually put those in there. You can see there is no period type source concept ID because something like a type concept is it's an OHDSI unique idea, calling something a type and having it represent a provenance. So there is no like source vocabulary feeding into this. All right. Any questions on observation period before we move on to visits? Okay, great. All right, so let's quick move into visits. I'm gonna again use encounters to feed our visit table. Now you'll see here we have visit detail and visit occurrence. So the way I think of it is visit details are very granular, and the table was originally meant to track patient movement in the hospital. And then visit detail is much higher level. So what you would have is visit occurrence is higher level. So you'd have multiple visit details that make up one visit occurrence. So you might see within one visit occurrence multiple movements between different levels of care, and that would be encompassed by one larger inpatient visit. So one thing I do want to do is I want to jump to a query. So I ran a few queries earlier. I'm sorry if this is small. I'm not quite sure if I can increase the font size here. But really what I wanted to show you is a couple things that I was observing in the visit table or in the encounter table in the Cynthia data, and some things I wanted to kind of bring up and show you. So I was doing some digging, and this is kind of an example where you have your scan report, but it might be really helpful to go back to your person level data as well to be like, okay, what am I observing? What do I see in my person level data? What kind of things do I need to handle, in this case, when it comes to visits, to make sure that I am creating the logic appropriately? Now, in OHDSI, in the OMOP CDM, we have some rules around visits, and you can find these on our common data model GitHub page I was showing you. But one of the rules are inpatient visits cannot overlap each other. So if a person is in a hospital, they are in that hospital bed. They're not leaving to go get an x-ray down the street. Like, they are in that hospital and they are there. But a lot of times you might see what looks like different encounters coming through the data during one inpatient visit based on how maybe the hospital is billing those encounters. You know, some providers, bill separately. You know, there's all these different things that kind of go on. But if a person is in a hospital, they're in the hospital. So I wanted to quick show you this here. So here you see, let's see if it'll work. Oops. Is it working, Max? Oh, let's see if I can. It won't do it here on the data itself. Yeah, it'll do it on the query, but it doesn't make my data bigger. So it's kind of annoying here. So I'm very sorry. So it keeps making my query really big. Do you guys want to join an internal KO discussion? It'd be really fun, really exciting. Yeah, I tried it. and it's just making my query really, really big. I know, it is really weird, so I'm sorry. It's like not making it bigger. Yeah, maybe that might be a good idea. Can we do that? Let's see. You have to go to what? Yeah. All right, well, here we go. Good call, Maxim. All right, so it's not perfect, but I've got this one patient here. I just really wanted to show you this one patient to give you an example. Like even in Cynthia, here are some things we're seeing. So this is a patient ID. Here's a start date and a stop date for an inpatient visit, and you see here we see when they are admitted. They are transferred to intensive care. They are then admitted to some ward, maybe a step down bed, and then there's a follow-up encounter a few days later. So if I was to take this verbatim, I would have 1, 2, 3 different visits, all related to the same inpatient stay. Now, that is not necessarily how we should actually be modeling this data, given the OHDSI conventions around visits. So the way that we think about visits, especially inpatient visits, if we see, in this case, this inpatient visit is ending on the same day that this inpatient visit is starting, that's telling me, well, this isn't exactly a new visit. This is just something else, some movement in the hospital related to this person. So I really just wanted to bring this up to tell you how I approach inpatient visits is I take things like this and I collapse them all down into one full inpatient visit occurrence. But all of this information, the transfer, things like that, that can all go into the visit detail table. So all that information is still retained, but you are getting that one overarching inpatient visit occurrence representing all of these different movements of the patient. Yeah.
So you're saying with a visit detail, we use clarity, so the ADT table should go to visit detail?
What is that what you're is that what you do, Roger? Is that what you do, Roger? Yes.
The only other comment I'll throw in here is that this is actually, I think, a big pain point.
Yeah.
And it actually was one of the focus. I don't know if anybody was in that vocabulathon, but there was a table that was dealing with visit because it's a pain point.
It is, yeah.
So I would encourage anybody who's doing ETL, that's definitely one area where, like it or not, there's actually a lot of clinical intelligence that can come, that's loaded into visit, right?
Mm-hmm.
An inpatient visit is a very different thing for pneumonia than an outpatient visit for pneumonia. And yet, this is in some ways a nice example because these are at least tagged as inpatient visits, but you can actually observe hospital encounters where you have outpatient visits while you're in the encounter.
Yep.
That's not happening, but they're going to X-ray or they're going to other things. And those
Exactly. Yep.
tagged as outpatient visits.
Hospital outpatient.
When I do a query, I can find all kinds of outpatient coronary artery bypass grafting happening. And that's not happening.
Yeah.
It's just that the OR visit is being tagged that way.
Yes.
So it is an area where I think we do need to do a lot of work as a community to clean this up.
Are you saying that we should do a roll-up encounter?
Yep.
Those different things, and then the second question is, what is the value of bringing ADT into visit detail? Like, I mean, we have our own warehouse and we do have those, but I don't, in terms of OHDSI presentation, is that valuable as well to have visit detail?
I'll defer to Clair. I guess it depends how you envision using your CDM.
Yeah.
Right? Like, some people will use it as their organizational data warehouse, and you want to track patient flow.
Yeah. Yeah. So. Yeah.
If you don't want to lose anything, you might want to have it. I defer to some experts on that.
Yeah. So it is. Oh yeah. Go ahead, Karthik.
I would say patient, I think it depends on your use, right?
Yeah.
If you already have a warehouse, like our OMOP is advanced for this. Yes, that's reality is OMOP can't handle all our needs for research and operations. But, we could probably merge like 80% of it. And so we put in as much as we can into visit details. OHDSI as a whole has never really used the visit details table. I know some groups have tried to do it for like the COVID time when they're in the ICU. There has been some They take care of, they will factor in date time. So if you're trying to look at how long does it take, you know, in order to a medication being
Yep.
administered, or how long are they on a floor for X, Y, and Z, the Odyssey packages don't handle it because they don't handle date.
Yeah. Yeah. So in summary, it is use case driven. I will say, so I brought up some logic here. Now, we populate visit detail for pretty much every one of our CDMs, but actually because we more use it as an ETL driver than for research. And what I mean by that is anything we have, not even EHR, but claim lines as well. So if you've seen a claim form, you get multiple claim lines within one inpatient stay. Same thing with like those outpatient visits you see, they become outpatient claims as well. Or like, say in my area, we have a separate network of emergency physicians that just work in the emergency room. So they have like separate billing procedures, and those come forward as outpatient procedures. So what we end up doing in our ETLs at Johnson & Johnson is we actually put everything, claim lines, any movement in the hospital, we put it in visit detail. And then we actually have built standardized logic on top of visit detail. So that way, I just have to shove everything in there. I map my encounters to standard visit concepts, and then I just roll them all up based on one standard visit occurrence definition. So that's why I wanted to show you that example. Yeah, Roger.
Are you putting the visit detail ID into all of your clinical tables?
Yes. Yeah. So the question was, are we putting visit detail IDs into procedure and measurement? The answer is yes. It's actually, so sometimes I use tables in different ways. I'm not going to say you should do this, but I am using them as ETL helpers for some of these purposes. So I actually use visit details to help me identify cost. Because to the question about, I think that gentleman might have left, the question about one-to-many mappings, if you are responsible for looking at cost in your data at all, I don't know, anybody using cost data here today? Okay, sometimes, when you have a one-to-many mapping, if you are not aware that is happening, it can make it look like the cost is duplicated, if that makes sense. So if you have a source concept that maps to two standards, it can look like that record is splitting, and depending on how you link it back, it can look like the cost is being duplicated. So I actually use visit details to link to cost, so I'm not duplicating anything. Now, is that the correct approach? Debatable, but it is an approach that we have found that works for us. That's a good question. All right, so I wanted to show you that idea of things you might see in the real world, but then when it comes to the Odyssey OMOP conventions, like for inpatient visit occurrences, they cannot overlap and they cannot have less than 1 day between them, because those should be strung into one visit occurrence record. So I have all this information here. I think this was in the email I sent out. I don't remember, but it's at odyssey.github.io/ETL Lambda Builder. So this is all of our documentation for our ETLs that we can share at Johnson & Johnson. So if you wanted some examples, we do have them here. All right. So let's see. Let me go back to, the rabbit and hat and white rabbit have the same icon, so I just guess every time. I'm not really sure which one it is. All right, so let's take a quick look quickly into encounter and visit detail. I'm already over, so I'm gonna try to go quickly. So what I would typically do is map encounters. So we've got our, our patient like we did before. We're gonna map to person, and then we've got our start date, and our stop date is gonna go to visit detail end date. The one thing I will say here in Cynthia, it tells you encounter class. Here again is where I would do kind of like with gender, where I would manually map. I'm like, okay, I see inpatient, I'm gonna map to 9201, which just is the standard concept for inpatient. Here we go. So here in visit detail, I would say set inpatient to 9201 and kind of go through those different options here. We talked about type concepts. There's some options here that as you go down, you'll see like admitted from. Sometimes you'll know, oh, this patient was admitted from home, this patient was admitted from a skilled nursing facility, that sort of thing. You can put those concepts here. All right. And then what I typically do is I look at the concept hierarchies for visits, and it sounds like they're working on them because they do need some help. But I look at the concept hierarchies for visits based on the visit detail concepts that exist in my data, and then I'll roll them up to those high-level visits of inpatient, outpatient, or ER. There's a couple others based on that standardized logic. Now, this may be much easier in your data. Maybe you have pretty discrete visits, and it's pretty straightforward. So that's up to you how you want to approach that. There are just some conventions around visits I would suggest that you adhere to, especially around the inpatient visits. Outpatient visits are a free-for-all. If you have multiple on the same day, that's very plausible. Maybe a patient like went to their primary care provider and then had to go get labs done at a separate location. Like those are very plausible. But when it comes to inpatient visits, you want to make sure that they are discrete. Yeah.
Right? Like they are occupying a bed inside the hospital, but they're billed as observation. Is that inpatient here?
If they are, the way we do it is if they are in a bed in the hospital, they are considered inpatient under inpatient care. Yeah.
Okay.
Yeah, that's a good question. But if you have those levels of care represented in your data, I might use visit detail to help identify that as well, because that's where you can see if they are in an ICU or they have higher levels of care. But the way that Odyssey defines it is like if you are in a bed in a hospital, you are an inpatient because you are receiving care at that hospital, and that's the only place you could be at that time. Good question. Any other questions around visits? I know I'm kind of moving pretty quickly. All right. Okay, so I'm gonna just do condition occurrence really quick. So the next one we have, let's see here. So I'm gonna show you one other query. Oh, it's so big. So what I did was, and Evanette walked through this a little bit, but what I did was I went to the native data and I said, let's look at the conditions that exist in the native data. I know that they are SNOMED, and I know some of them are ICD-10. And then what I did was I mapped them to standard concepts because I wanted to know what domain do they end up in. So that's a big thing. I assume you guys talked about that a little bit in the intro tutorial, but where the records end up in the CDM. So if a record ends up in condition or procedure occurrence or drug exposure is solely related to the domain of the standard concept your source concept is mapping to. And that is because if we all put our data in the same tables based on the same heuristic, we always know where to look for it when it comes time to generate evidence together. So we always should be relying on the domain ID of the standard concept to tell us where our data should go. So my point that I just wanted to share with you here is, yes, this table in Cynthia is called conditions, but when we map those codes in that table to standard concepts, we are seeing both observation domain and condition domain. I know it's a little hard to see, but that's really what we need to focus on. Is just because your source data is the condition table doesn't mean that's where it's going to live in the CDM. That movement is solely driven by the domain of the standard concept. All right. So one other thing I wanted to show you here, and you're probably wondering, where did you get that table called source to standard vocab map? Now, in the slides I sent, let's see, this is probably a little bit easier. So in the slides that I sent out, you would see this source to standard query. So this is what we actually use in our ETLs, and this is showing you how you can effectively map your source concepts, to standard concepts. So what it's going to do, it starts out and it looks first in the OMOP vocabulary for a mapping. So you can see that we're joining to concept relationship, finding that relationship ID of maps to. So that maps to relationship is what is telling you, here is where that source concept ID, here's where it maps to the standard concept ID. So that's the really key relationship. So we first look in the OMOP vocabulary for a mapping, and then we also look in the source to concept map table. So if you are in the state where you are mapping a lot of your records by hand, you might have stored those mappings in the source to concept map table. This is a really common practice where you have those like free text fields, and you can put those mappings, whatever standard concepts you have defined for those free text fields, you can put them in the source to concept map. So we're looking in both places here to find a mapping. And so really that is just this table here. I ran that full query against all of my vocabulary, and I saved it as a table in my CDM so that I can just reference it whenever I need to. Not necessarily has to be everyone's approach, but if you were wondering, that's where it came from, and you do have those queries available in the slides that I sent out. All right, so let's quick go through the condition table. So we know already that we have some of our codes in the condition table. When they map to standard concepts, they have a domain of condition. So we are going to go ahead and map those two tables to one another. Again, we've got our patient going to person ID, which we can look up. Oh no, why is it doing that? There we go, thank you. I didn't know it would just still do that. So we'll map our patient to person ID. And then in the condition table, we do see an encounter ID. So in this case, what we could do, this is how we might link a condition back to a visit, for example. So this is how we can use the visit detail table and the visit occurrence table to link back to this encounter value to say, okay, this condition occurred during this particular encounter. So what I might do here is map that down here, say to visit occurrence ID. Now, of course, this is not going to be a one-to-one mapping because this is an alphanumeric, first of all, but also as we were just talking about, we might roll visit details and encounters up to higher level visits. So in the case of Cynthia, what you'll see is we have some intermediate tables we have developed to help us figure out which encounters happen during which conditions happen during which visits and which encounters map over to which visit occurrence ID. So there is no rule that says you can't create intermediate tables. You certainly can. You can even add columns to the CDM to house some of your source data if you need to. There is no rule against that either. All we ask is that you don't change the standard columns as they exist in the CDM itself, because those are the columns you need to conduct network research. All right, so then what we're gonna say is we've got our code here. So our code is gonna go in condition source value. Again, we retain all of the source information, so the verbatim code will go into condition source value. And then the first thing we're gonna do is we're going to find the source concept ID that represents that source code. So what we would do is we would use the vocabulary mapping query like I just showed you, and you can find that source concept ID that represents that source code by using the system information. So in Cynthia, they call it system. What I would do is I would say, okay, let's look up, let's see if I can click on it here. All right, so I'll say, look up the source concept ID using the system value and source code. So then we'll find the source concept ID, and then again, using the source concept ID, we will then look up the standard concept that is associated with that source concept ID using that mapping query. Now, I tend to just map the code, and then in this case, we'll do system as well. I tend to just map those both to the standard concept field, just so that in the documentation, what it shows up as is like, okay, this is the source of this information, but I'm really going to be like map the source concept ID to the appropriate, if I can type, standard concept and put that standard concept here. So I like to retain kind of like where this information is actually coming from when I'm building my documentation. But in reality, this standard concept is going to be mapping from your source concept using those vocabulary mappings that are available for you in the tables. All right, so I'm a little bit over, so I'm going to stop there. I know this is kind of like a whirlwind through it, but what you'll end up with, like I was showing you, is some documentation that might look a little bit like this. And you can see here, these tables end up looking like this here. So you've got the destination field, the source field, where it's coming from in the native data, and what rules you are applying. So at the end, you'll have a full document with all of this information, and you can add additional information to it like we have done here. And so here's what it might look like for an EHR data source, where you've got full mappings from the source columns over to the CDM columns, and then logic filled in throughout. So that's really what we've been building here, is this documentation. This is not going to build code for you, and Max is going to go into that. But that's what really we're deciding here is, what logic do we want to use to get our data from our source system over to this structured format using standardized vocabulary. All right, any questions about that? I know that can be sometimes a confusing process. All right, hearing none, I'm gonna then turn it over to Max, and he is gonna show you some options for how you then translate this document into an actual, actionable code. All right, here you go, Max.
Thank you, Claire.
Yeah, absolutely.
Thank you so much, Claire. That's very a lot, right? It's kind of overwhelming. It took me like many days to understand all the conventions and stuff, but I think it takes time, and if you go through them by yourself later on, you get to understand a little bit more. And then mapping, you will learn through the process. And for example, at my hospital, the first time we map like the logic or the documentation stuff, it took us several months actually to build that documentation. All right, I get the slide up. Okay, awesome. So once we get the documentation, the spec or everything could be like a spreadsheet, could be from Rabbit in a hat, right? And that's just telling you what to be like the source of the data and what to be the final mapping or the logic stuff. But the code, the data doesn't convert itself. You have to write some code some code to convert them. And that's the topic that I'm interested in and I have been doing that for many years. But before we get into the coding part, we have to ask ourselves some of these questions first, like normal other ETL projects that you have to do, not limited to OMOP CDM. First, you have to understand where is your data. Is it in a data warehouse? Is it what kind of database it is? Is it a like a data lake? Do you have access to it? Do you have to ask for access or get like a sample data to work with? So that's the first thing that you have to work on. Also, I work on some of the project that the data is so large, like a national level data, and that's like a big data that couldn't fit into your machine or into your RAM. And you cannot use like a typical database. You have to use like Hadoop or cluster distributed database stuff. So the choice of tool or the choice of coding or tool that you have to use is going to be different from not so big database. Like for example, at my hospital, we have data about like several hundred million rows, and that's not a big data because you can fit all of them into the RAM and run that efficiently on your normal database. Right. And there are also like complexity of the data, and sometimes it could be not easy to get access to the data, so you have to prepare that in advance. And some of the data, like from the applications, they might have encoded some logic or some assumptions, like OPD visit have different way to encode information than IPD, inpatient visit, for example. So you have to work with the clinicians or data expert to understand what's going on in the data set. And you have to think about how many times you want to refresh the data. For example, at my hospital, we refresh it weekly, and it's doable. So we do it on the weekend when nobody uses the data warehouse. Also, there are many tools out there that you can use to do the ETL, to do the coding. Even though like R is the main language of OHDSI, you don't have to use R for the ETL. You can use SQL, you can use Python, you can use other tools to do the ETL. There is no enforced standard to do like the ETL convention, but you have to follow the spec, right? The final product has to be following the standard. And I have several choices of tools that I worked with in the past, and here is a summary. So first group is the custom script. You can write your own package. You can write your own R, Python, SQL package. For example, ETL Cynthia that we got to go through today is one of the packages that Clair, Evanette, and Frank and Anthony made. And we go through that as well. The strength is that you have full control. You can do whatever you want with the data and the way you like it to be. And you don't have to security concern. You don't have to go through that. But the problem is that it can be sometimes difficult to manage because you write your own code and sometimes you make some, fixes that unconventional, let's say, and perhaps somebody else, new developers, cannot understand what you wrote in the past, and that happened to me many times. So that's a challenge that we have to deal with the custom scripts. Or you can use commercial ETL tools. There are many of them. Like my hospital used Microsoft SQL. Microsoft SSIS, I cannot remember the full name. And yeah, but we have it implemented in the organization already, so the security, everything has been vetted already. But sometimes it can be like a GUI, and it's not easy to deal with, so yeah, and license can be costly as well. Or if you have like data on the cloud, perhaps you can explore the cloud solution that come with your cloud providers. And what I have been exploring in the past few years was the open source data transformation tool like dbt and SQL Mesh that I'm going to show you some example today. So because it's kind of modern-ish, it has a lot of features that make it easier to develop, has very good developer experience, let's say. But of course, the features can vary a lot, and you cannot sometimes, there are bugs and errors that you have to fix them by yourself, so that's something to consider. So what we're going to show you today is the ETL Cynthia. This is on OHDSI GitHub repo. You can follow it. You can go to this repo and see all the codes there as well. Other library on OHDSI, it supports many databases, and today we're going to use DuckDB to demonstrate it on your local machine. All right. So if you want to follow, you can check out the tutorial repo that you have access to I believe you have the link in the email as well. And you can install it and use R. And in that repo, you will have the OMOP vocab files and the Cynthia file in that repo. And we will spin up a local DuckDB database for this demo. So at the high level, the steps for the ETL Cynthia is just download the package. You download the package first, and then you connect to the database that you want. It could be DuckDB, it could be Postgres, it could be Microsoft SQL, so it could be many other databases you have data on. Then we populate the database with our data. So we have the Cynthia and the vocab data, we populate them. Then we load the data. Yep, we load the data into the database. And yeah, we're gonna execute some SQL commands to do the conversion from the Cynthia, following the logic that Claire showed you earlier. And so this is the ER diagram. If you are data nerds, like I mentioned, so you would like to have these. You might want to have these handy, and it's on the link here as well. So you can see there are many tables that depends on each other, like the relationship between them. You can see all the links there. Yeah, I have it printed out and it has been very useful. So I recommend that. But when we do ETL, we cannot do everything all at once. We have to start somewhere, right? So the recommended first table to start is the person table. I think it's quite simple, and if you get it right, it's gonna be like a baseline for all the race that come after that. And don't forget the concept table as well, and also the dimension table, location, case and provider that other tables depend on. So for the concept table, there are several versions. You can download the standard concept from Athena website, and it's going to be a huge file, like 5 gigabytes, I remember. And that's for the standard concept. But if you have like a local concept code, like in Thailand, for example, we don't have all the code on Athena, so we have to run like local mapping. There's a tool called Usagi, and you can download it and it's a Java application that you can run it on your desktop. And I also have been developing like a Usagi on the web version, but I don't know whether we're gonna have time to demo it today. But I'm gonna present it tomorrow at 3:30 at demo 503. So if you have time, you can check it out. So hopefully. Well, it's not fully functional yet, but we will try our best to get it functional and then make it easier to do the local mapping and do the collaboration like real time online. All right, let's start with the person table. So Claire just did that, so I can quickly skip this, and you can check the website for all the logic behind all these arrows mapping. And also behind the arrows, you have this logic, like you want to map gender, male to 8507 and female to 8532, for example. And there are going to be a lot of logics that you have to follow and to implement them in the code in your ETL pipeline. All right, this is the fun part. So you're welcome to follow this, but I'm going to show you like on my laptop as well. So if you go to the tutorial repo, you can find the ETL directory and then go to ETL Cynthia, and then you can scroll to step 8 and click insert person. I can do that to show you where it is. So let me open the website. Yep, I have it here. So here you have 3 versions of ETL that I put up there. So there is a DBT1, ETL Cynthia, and the SQL Mesh. First, let's do the ETL version, the R version ETL Cynthia. And if you scroll down to version, step 8, you can follow the instruction here. But usually, I think it takes a day to run this full workshop. So that's why I have to condense this into 20-minute session. So if you go to step 8, you will have this insert person SQL. You can click on that. And this will bring you to the original ETL with. Let's assume that it works. It should work, but I don't know why. Okay, don't worry about it because I have it on the slide as well. So, all right. If that links work, you should get this SQL code. I hope you can see in the back. So basically it's one long script. I have to split like 2 columns to make it fit on the slide. So it's just a simple SQL script to convert Cynthia patient table, like Cynthia patient, to OMOP person table, right? So what we do, we first start doing this select block from Cynthia patient, and then we do the mapping. So usually just case when logic. So from the spec earlier, we have gender male to 8507, and we do that here as a SQL script. That's pretty straightforward, right? But sometimes it's not that straightforward. For example, you want to map the concept from non-standard to standard concept. You have to join other tables. And in this case, we don't do the concept. We do the location. So we usually write a common table expression or CTE to convert to map the US state abbreviation to the full location ID. So we call this table that we built earlier, like in the pipeline, and then we do the join. So we do the CTA map state, and then we do the left join to get that information and put it in there. So instead of case when, we have to do the join operation here to get that information from other table, and then we map these to the ID. Concept ID, similar approach. Right. You do the join. Then, as we mentioned earlier, if we don't have the standard concept, we can use 0 as the number for the concept ID, so that we don't have to, so that we avoid the now problem later on. And after you have done the select block here, you just insert them into the table, right? As you can see here, there are some dependencies. So this person table depends on the location table and also the state maps table. That means if you run your ETL, you have to run these dependent tables first before you can run the person conversion table. And this can be represented as a table level lineage, data lineage. So if you write your own script, you have to do this manually. But if you use some of the data transformation tools like ETL tool like dbt or SQL Mesh, this is built for you automatically. And so that's why I like to use this tool because like when you have, so you can see here, person table depends on stage, patient ID table, patient location table, state map, and the patient table. So you can see that you have to run many these table ahead before this final table that you want to have in OMOP CDM. And yeah, if you study the ETL Cynthia library, you will see these steps in the library that you have to execute in order. But if you use some of the tool here, like for example dbt, you can just write your code in SQL, then you just write command dbt run, and then it can populate all the table for you. Also the same for SQL Mesh. You can run SQL Mesh plan or and then SQL Mesh run to populate all the data. I can quickly show you how to do that. So let's start with how am I doing with time? I have 5 minutes, I guess. Okay, all right. So if you open the tutorial ETL repo, you will have all the instruction to run this on your laptop. And yeah, I think the most challenging part would be install the R and then also the OHDSI R packages. You have to follow this hard disk installation, and you have to set up Java and everything. So that could take a while. But yeah, but if you set it once, you can run other OHDSI packages as well. I said that already. And then you can download the tutorial. It comes with the data in this folder. And then because I have everything installed, I can run this script. So let's try it. Let me delete my existing database first, so it's run from scratch. All right, so let's see whether my real demo, like live demo, gonna work or not. All right, so I just run this command. Hooray, it works. So yeah, it works. So if you want to study the script, you can do so as well. So everything is comment. I have the comment and the explanation in the README what's going on there. Yeah, I did that. I studied this like when I first started doing the ETL. It has been very helpful. So thank you to all the creators to make this demo out there. So we finished the conversion. I can quickly show you the data, the final data. So I like to use dbeaver as well, and luckily Clair, well, not luckily, but thankfully Clair has a problem earlier, so I have time to set up my dbeaver to make it large. Right. Oh, it's in CDM. All right, so if you run this on your machine, you hopefully should get these beautiful OMOP CDM tables in CDM schema. And you can see all the beautiful data there, right? So yeah, it works, the script works. And let's try something else. So I have dbt and SQL Mesh version as well. So I can quickly do that. Again, there is an instruction in the repo, or if you run it today and you have question, I am here today and tomorrow. Just ask me, you know. All right, quickly, I will remove the database first. I removed that already. And I just follow the instruction that I put on the README, and I did that part, okay. So let's skip to step 6. So I can run dbt debug. And this just make sure that, okay, I have the connection to the DuckDB, so it will create DuckDB local file here. And then I'm gonna run dbt build, which basically run 3 commands, dbt seed, dbt run, and dbt test. So run that again. So what you can see here is that it load the data into the database like ETL Cynthia earlier and do the conversion, and also run the test as well. Everything is perfectly executed. So you see we have 234 conversion, 234 steps done in one go, and yeah. And the data will be the same, looking the same as ETL Cynthia earlier. I can also try SQL Mesh as well. So same thing, let me delete my database first. And then I have the README. Again, I'm gonna skip to step 5, SQL Mesh info. Now it generates the DuckDB file and get the connection set up. And I can run SQL Mesh plan. It will ask whether I want to confirm the conversion or not. Yes. Again, similar thing, but there is some problem with the input file, the format that it's just a warning, it's not error, so it loads perfectly fine. And you can see here the same stuff happens, so it runs all the commands in order, and then run the audit test as well. So I have some DQD tests implemented in the ETL pipeline, so that when I update my data, it runs the DQD test automatically in SQL Mesh as well. So, all right, I'm running out of time. And okay, so this is some example of the database of the SQL command. It's like the ETL Cynthia earlier, but in dbt you have to write some of the Jinja tag to tell where to find the database. But in SQL Mesh, you don't have to write the Jinja tag. You can write everything in SQL, and then it will, the dbt and SQL Mesh will recognize this dependency and build your lineage for you. And the full project, for example, this one is a demo project. The graph, the directed acyclic graph gonna be pretty complicated, but the real stuff, like in my production, is a lot more complicated. But thankfully, I don't have to do this manually, and also we don't have to execute everything all the time. We can select some of the model when we do the development. I usually select some of the model and run it upstream and downstream, so that we don't waste all the time waiting for the transformation to finish. And there are many other resources out there. You can find the language or like the tools that you like. For example, you can use .NET, you can use AWS Lambda that Claire showed earlier as well. And there's also a version on C# that Claire has been working on. That's all for me. Thank you. Yeah, questions?
Thank you so much for a wonderful presentation. And you make things look easier, but I'm pretty sure that it's very complex. But my question is, are you aware of any automated tool that makes these things really easy? I don't know, even using Gen AI that replace some of the steps mapping that were demonstrated today?
Yeah, that's interesting. I have to say that I built my stuff before the Gen AI age. So I built everything manually. I haven't tried Gen AI. It could work, but I use Gen AI for OMOP, other OMOP stuff, because OMOP has been around for over a decade, so it has like learned all the pattern. But for the ETL, I'm not sure, or anyone has tried. You can check. Oh, yeah. I think I think one more consideration is that when you do the map, like do the coding, sometimes the data is not perfect. You have to make some assumption, and AI can make bad assumption for you, right? So, and if you trust the AI, you will never know what assumption it made. So what we do actually, like we cannot get the perfect OMOP CDM like converted from our database. So we document what we made assumption for, and we can come back and correct them later on.
Thank you.
That said, as a start, I can see just either the specification of even just your source model saying, I want to convert that to the OMOP CDM, and have a very inclusive template to go through. And that could save a lot of work going through all these steps. So yeah, but that's a bit of new ground, as most ETLs, as Max said, are developed pre-Gen AI. One other question, more fundamental, as in, have you considered here going through ETL table by table or patient by patient? Do you have experience with, what is your main approach here?
Well, what we did, we go through table by table actually. So we kind of follow these steps, and yeah, we build the person first and try to add more information. Yeah.
Just to say, so I think most ETLs are built in it first populate the whole person table and the whole observation period, going through this list. But you could go through this on a person by person level. So for a person, populate the person table, observation period, visit occurrence, etc. That's two. I think I've seen both. The two ways to implement that.
Awesome.
All right. So let me switch around. Yeah, where we go from here. So now we have data in the OMOP CDM. Now we can do exciting things. But first, we have to evaluate our CDM. Let's move to the right slide. There we go. Yeah. I'm Maxim Moinat, by the way. I think 8 years ago, I was basically in this room. Now I'm like 8 to 10 ETLs further, and happy to give you share some experience across this line. But I will focus on the data quality. There are two things I will show. The data quality dashboard and more characterization, so Achilles. So one will just go through checks. So is my data coherent, conforming the OMOP CDM conventions? And the other is more exciting, looking actually at plots, looking at your data. What's in your data? Start exploring a bit. So the goal, make sure your own ETL functions as expected and produces a specification-compliant OMOP CDM according to, so that's all built around the software development lifecycle, and we'll cover these 4 areas, starting really briefly with the test framework. This is built into the Rabbit in a Hat suite. You can export a test framework where you can set up a, I would say, I think it's called unit test in Rabbit in a Hat, but it's actually end-to-end test, where you define upfront some input data and then test it as expected output. Why is this important? Well, ETL is often complex, as Max has shown, and there's an increasing danger that mistakes go unnoticed. So I want to check that. And also, ETL can be time-consuming. Well, in Max's example, they went pretty fast, but often they might take days, weeks, maybe even a month to run, depending on your infrastructure available and the size of your data. You don't want to find out at the end of your ETL process that something gone completely wrong and you have to redo that. That's very time-consuming. So that's where these unit tests or end-to-end tests come in. You can define this in many ways. If you want to comply with, say, the ETL Cynthia, you can do this in R with this test framework. And I'll just give an example of 2 tests that you can write using that framework. One very simple, where we simply define a test ID. This is just populating condition occurrence table, given a patient and a condition source record. I expect that I get a condition occurrence record out of it for that particular person. But we can also make that a little bit more complicated. So is, for instance, also vocabulary mapping as expected. So now I give it a condition record with a certain code and the mapping of that particular code. In this case, it's an ICD-10 code. And then I expect, on the last line, my condition occurrence to have a certain condition concept ID. And we can make these more and more complex, of course, and for specific cases. So we can test when we put in a date that happens in the future. I expect maybe that this should be filtered out. So I don't expect a condition occurrence record. Or missing data in general. What should I do? And test that particular logic. Then moving on to the data quality dashboard. This package was developed by Clair and others from the Odyssey community to consistently test a bunch of rules against your final OMOP CDM. So this will be run after you completed your full ETL process. You have your data in the OMOP CDM. Is this now compliant to the conventions? This open source R package, you can find it on GitHub. Also has a nice documentation page, currently maintained by Katie Sadowski, who has moved it actually as part of the Hades suite of tools. It's this suite of R packages adhering to certain practices. We have here 25 data quality check types, which I will go into a bit more depth in a minute. In total covering around 2,000 individual data quality checks. You might see this number in also previous presentations differ a bit. At some point we had 4,000 checks as well. It turned out that when I looked into this, it depends on your exact settings of data quality dashboard. But with the default settings, you get around 2,000 checks. The results can then be exported to JSON or a CSV, even or a table, and then visualized in this R Shiny app. And that allows you to explore, maybe with your data scientists and data engineers,
the results of this check. Just as a brief glimpse, I will also show this on the actual Cynthia run, but this is what it looks like. So we have here 5 checks, a result of 4 checks actually. It has a failure status, it has a description, and the percentage of records failed with some additional metadata. But how is this actually calculated? And how do we determine whether a check failed or not? To introduce that a bit, we have a very specific definition of a data quality check in the context of the data quality dashboard. And that is an aggregated summary statistic that can be computed against a data set and to which a decision threshold can be applied to determine if the statistic meets expectations. Let's go through that. So first of all, so we have a statistic that can be computed against the data set. What do we mean with that? For example, one of the checks we define as the number and percent of records with a value in the days supply field of the drug exposure table less than 0. That's a very exact definition, and we can write a query against this table and this field to check whether that's indeed true. And then we get a number of records that fails this check. But you can get a step further. We want to do this consistently over all tables and all fields that have some numeric value that should not be below a particular threshold. So we can generalize this check. And then we get the template would then be the number of percent of records with a value in the CDM field of the CDM table less than a certain low value. And this is the definition in this case of the check plausible value low. We can do the same again. So here, number percent of records which are not mapped into a standard concept in the conditional concept ID of the condition occurrence table. That's for one field, one table, and we can generalize that to all fields and tables that have or should contain a standard concept. This is the standard concept record completeness check. So while developing DQD, Clair and others from the Odyssey community went through what should we check for and came to these 25 check types. I think at the time there were 20, but we expanded it a bit over time now to 25. You can find this all on the definitions of each of the checks on the documentation pages. I will highlight a bit how this is structured. I haven't gone into these categories, by the way. That's all based on a certain data quality framework, the CAN framework, I think a paper from 2018, where this is laid out how to check your real-world data for quality. We have conformance. That's basically, does your data adhere to the database constraints? Primary key, foreign key, data type, and the fields, whether the OMOP data, OMOP fields and tables exist. Then I want to highlight, let's first go to completeness. So that covers, is the data fully populated? Is the data complete? Do we have records in the person table? Do we have records for the persons in observation period table, etc.? Do we have standard concept? Is specifically the condition era table field given the condition occurrence table? Very specific check in this case. What I want to highlight here just to show the difference between conformance and completeness is that we have a standard valid concept check that, and I have to phrase it correctly, that a field where we expect a standard concept, indeed this concept is standard and valid. So does it conform to the OMOP conventions? Then under completeness, we have a standard concept check, and that looks for how many of your records have a standard concept and are not mapped to a 0, as in have not been mapped. Because a 0 is a standard valid concept, but it's not complete as you're missing a target mapping. Then lastly, we have plausibility. And those are the checks that typically need some external source of information. For instance, there's actually 2 checks checking for whether the gender, or actually biological sex, conforms to the condition occurrence. Actually, the other way around, conditions diagnosed that are specific for a particular sex. Do these persons indeed correspond to the sex? Like testicular cancer, likely in males. If you have females with testicular cancer, might be a data quality issue, might be a characteristic of your data, some other thing going on, something you might want to investigate. We actually added a few additional here. We now have a after birth, before death, and a start before end check that will replace the temporal after and during life checks that will be deprecated in the next version. We actually this Thursday in our working group we might start to think a bit more about new checks to implement, like things like observation period overlap that should not happen, prevalences, and also inpatient visit overlap that Claire mentioned. So we're continuously updating this, adding more checks, etc. It's really nice to have this template to work with. Then the second part of this data quality check definition. Given we compute all these checks, we need a decision threshold to determine if the statistic meets expectations. So all these checks can have a failure percentage from 0 to 100%. 0 meaning all pass, 100% meaning all fail. Somewhere along that line, we want to say if it fails for more than 5% of my records of my table, for instance, then I should do something. Then I should see if I can fix that, investigate. Below that, we might not want to take action. You might think, you can't say that for all, of course. Well, that's why we can set per check, I think even per table or field, what the thresholds should be. For instance, in the person table, we expect all persons to have a record in the person table. But not all persons might have a measurement because you just have lab results, so there might not be a record for every person. But still, we would expect it for at least 10% of records of persons we expect a record in the measurement table. That's where the threshold comes in. And we identify 3 different checks, or different check types. We have fatal checks, that the threshold should always be 0, so it should never fail. We have CDM convention checks, where in theory it should be 0, but it may need to be adjusted in practice because of, well, real-world data is messy. And then we have characterization checks that really depend on the expectations of the data source or even your use case. And this is all documented now on the data quality dashboard within the check level documentation. I think that's really nice to understand a bit more of the checks. We spent a lot of time on this to define this properly because we realize sometimes the check types are not that easy to understand. So if you want to start with DQD, data quality dashboard, I really recommend you to look at these definitions first. And that's actually what I want to do with you. To set up my screen slightly differently. Oh no, this will work. Any questions so far? I want to do a bit of a demo of DQD now. Let's see the time. I think we'll be fine. Yeah? All right. So this is the GitHub IO page for data quality dashboard, the whole documentation. I will make this a little bit bigger. So firstly, the check types documentation. So for instance, CDM table. Do all the OMOP CDM tables exist? That's a fatal severity. And it's all described how we evaluate this and what you should do when this check fails. Well, it might be quite clear in this case. Another example with within visit dates. Is a certain event within the visit, the start and end date of a visit that it corresponds to. We have classified that as a characterization check. And also here I provided some guidance what to do when this check fails. both from an ETL developer and a data user perspective. All right. Then you might be thinking how to start with the data quality dashboard. Getting started. How to execute data quality. I won't do that live. We'll take it some time, but it's all R script. You pass it to connection details and a whole bunch of settings. Looks like a lot of code, but actually it boils down to giving this particular function the right settings. Most of them aren't even required. It executes all these checks. We can even disable some checks if we want to, all configurable. And that will give you a JSON file, basically, that you can then load in to launch the viewer of data quality dashboard. And that's where I want to pick up this demo. Let's see. So this is the dashboard for our 109 persons of the Cynthia data that we have just mapped to OMOP. And now we want to see, is this any good? And this dashboard, make it slightly bigger, should give us some insights. All right, let's see. We have a big black number. It passes for 99%. So it's run over 2,000 checks, actually. 99% passed. What do you think? Is this, we're happy? Can continue to the next step? Anyone thinks that it's not good enough? Okay, is he satisfied? Cool, we're moving on. No, actually, so I find this 99% a bit misleading. Because 17 checks fail. These might be fatal things. We can't see that in this dashboard. So we always want to inspect those 17 fails here. They might be trivial, but they might be also very crucial that affects all following analysis. So let's take a look. And that's the second part of this dashboard. We just not only have this overview, a bit of metadata. Can ignore that for now, as we know what version of the data this is run on. But then we have a table with all the results. So basically, it has all 2,000 entries, all results. And I always like to give this a little bit more focus. We can actually read it, sort of. I'll make it a little bit bigger. I think we can even, yep, there we go. So what we do, let's filter this table to all failures. One thing I forgot, except for failure and pass, we also have the status not applicable. This means basically that the check has been run on an empty table or empty field. And then by definition, it will actually have 0 failures, 0 violating records. So those have a special status. Might also be that a check actually has an error. So just the SQL failed to run. That's also a special category. That's often more to do with DQD, that something is wrong in the database. Maybe fields not existing, etc. That it just, the SQL was not valid. In this case, we want to look at the failures first. Let's list them all 17. And I just want to highlight a few to see. So this is already ordered by percentage of records failed. Let's just take a look at the first one. So we have in the cost table, the is foreign key check that failed. So all the records for the cost domain ID field in the cost table does not exist in the domain table. So apparently, we did not follow OMOP conventions here. DQD also won't show you which records failed and what is in the cost domain ID. So the next step would also be to then look into a bit more details. We can see here all the details of the check, how many rows actually violate. But more importantly, we see the query that has been run to determine this for this check. And that has a portion that says violated rows, begin and end. That is the query that you would want to execute then on your database to see which records fail. In this case, it's all, so it's actually quite trivial. And what's actually in this cost domain ID in this case. Let me give another example. So we have in the drug exposure table, the plausible value low has failed for the quantity field. So apparently the quantity of drugs, medication given is less than, well, a very small value. So we have either a quantity of 0 or even negative quantities. That's odd. You always would expect that there's some quantities given. So certainly something to investigate. Then one that you will run into a lot are the, let's see, the measurement standard concept record completeness. This shows the number of records with a value of 0 in the standard concept field unit concept ID in a measurement table. So 32% of records, of units, have not been mapped. So that means for a quarter of your measurement records, you're missing the unit. We could not map it to a standard concept. For the unit, it might be trivial, but if this is the case for your actual condition concept ID, you might be missing conditions, source conditions, diagnosis that you could not have, did not have a target concept ID for. Your data users will look at this closely, like what am I missing here? What source codes could not have been mapped? And then lastly, I want to highlight the here the observation period failure, the measure person completeness, because this is quite a critical fatal check that failed. The number and percent of persons in the CM that do not have at least one record in observation period table. 4.5% of persons don't have a record in observation period table. And every person, according to OMOP conventions, should have an observation period. Otherwise, they are not observed. What are they doing in your data set? So this is the way you would want to go through this. One last note. If I'm looking now only at the fails, but given these thresholds, so this is what, the percent of violating checks is above this threshold. But let's look at the passes, because there are some that actually have violating records, but do pass. For instance, the node table here, completeness, there 100% of persons do not have a record in the node table because it's empty. Well, if we haven't populated the node table with ETL, that's fine. These things get more interesting if you scroll down and look at the records that have a smaller number violating, like this measurement measure value completeness, which says the number and percent of records with a null value in the values number of the measurement violates for 23%. Could be an issue, could be not be. Depends a bit on your data, of course. But I will always advise to look at these that are passing with a certain percentage. But that's a lower priority, I would say, in general. But there could be some interesting things in here that you would not expect. And then you can actually adjust the threshold accordingly for a next run. But I won't go into detail here. You can all customize it to your own data. All right, so that's all I had on DQD. For the last part, I want to go into Aries, but if there are any questions, let me know. Yeah.
Actually, a couple of questions. One is, this report from the DQD doesn't give you any clue on whether those failures were associated with the ETL process or came from the source data.
Yeah. Yep. It's both evaluating the quality actually of the source and your CDM. You actually don't know indeed what the origin of the source is, of the issue is. So it always requires some investigation in both the source data in your ETL and the own CDM data to figure it out. to catch that a little bit. So with White Rabbit, what we've done on the scan reports, you already know what you expect in your source data, what is there, what you expect. With the unit test, you kind of covered the most cases for the ETL itself. So now we're looking at the whole process indeed, at the end result. Are there any quality issues here? Yeah.
Okay, thank you. And my second question is, so all these 25, I believe, or measures or rules are predefined with DQD.
Yeah.
And so the thresholds are already prefixed in there, or they are customizable.
Yep.
And if they can be customized, if there is any rule like getting like a histogram or the frequency distribution and then adjusting a number of standard deviations or something like that.
Yes, so these thresholds are fully customizable. So that's actually one of the input parameters you can give the DQD scripts is the thresholds. I see most cases people use the defaults actually. We had intended it to be fully customizable, that each site would customize their own. So we have to look into that, maybe how to make that easier.
It is hard to change those thresholds, I would say, based on how it's currently set up, like you're saying. We've recently been actually updating the thresholds, and we have notes in there as well. So there's a way when you update the threshold, you can write a note. And for example, we had something where we were using the episode table, and in all of our CDMs, there was a failure on the episode table, and it was because we were using a concept that was non-standard, and we knew in the upcoming version of the vocabulary it would be standard. So we put a note in every single one so that when we looked through it, we said, yes, we know this is failing right now, but we know that it's going to be updated in future. So we actually did a big push earlier this year to like go through all of them and update thresholds where required and like fixing different things. It is a little bit tedious, but there is that option for you, and we've been doing it honestly to even talk to our past and future selves rather than necessarily for our researchers even to go digging into it, so that like when we see something come up, we have a note and we say, okay, we know what happened here, we know what's going on.
Yep. Claire, it's another question. Yeah.
For your like the unit testing examples, they were pretty simple. Like I think mostly around constraints of like, okay, if this quality of the patient is met, like we wouldn't insert the data. Can you talk about, is there any more complex examples where you are able to use unit testing effectively?
Yeah, you can make these as complex as you like. Throwing in the trick with these unit tests is to make sure each test tests one thing only, and not try to test whether the date is correct and the concept and the source value, etc. Then it's very difficult to trace the actual issue once that check fails.
So when you have like let's say I have my whole long SQL script that like creates a whole like my visit occurrence table or whatnot, that would then have to be many different unit tests that
yes.
each of those individual components.
So that's the big difference also with. So that's where DQD actually comes in. Just look at my whole visit occurrence table. Does that meet the specifications, the conventions from OMOP? But on a record level, then these unit tests are really nice. Say, given this input, this particular encounter record, say, I expect this visit record, this one record, or maybe two, but it's very precise, very
when the output is coming from like a whole SQL script, are you, in that example data, how are you kind of putting it through that process to then test the output?
I can speak to that for another hour.
Long time, yeah.
It's not trivial how that test framework is set up, but you're correct. Actually, what it does here is it sets up a whole source database with multiple persons. Each for each person, it tests one thing you want to test. Then you throw all the data through your ETL, but it's a relatively small data set, of course, because all predefined.
Yeah.
And then you test that output data against all those rules. You could do it even more isolated if you want to, but that depends on your setup, where you really just pull one patient, one record through your ETL.
And
but
run that through
it
the whole
depends
thing.
on the setup.
Okay.
Several ways to approach that.
Okay, great. Thank you very much.
Any other questions?
then I want to move to Achilles and Aries. So that's the last part of this evaluation, where we look more at the characteristics of the data. Again, Achilles, open source R package. I think it exists already from the beginning of the Odyssey times. One of the first packages, I think, developed on the OMOP CDM. And that makes sense because it's quite fundamental, because it just characterizes your whole OMOP CDM. So descriptive statistics, person, concept counts, stratified by certain metrics, distributions of numeric values. I think in total about 300 analyses that it does. Again, part of the Hades seed. And the results can be visualized either in Atlas. You might have seen the Atlas data sources tab. That data all comes from Achilles. It's all pre-generated statistics that then are visualized. What I will show you here is actually how to visualize that in Aries. Not so much how, but what that looks like in Aries. This is maybe one of the lesser known Odyssey tools, although it's out there for a few years, developed by Frank De Falco. It's, I think, it's on Vue JavaScript framework, which can be used to explore both Achilles and the data quality dashboard results. That's all in one. Very powerful tool. You need some expert knowledge to set it all up. But once you have set it up, it's really nice. And I will just briefly show what that can do. It can look at a single release. It can look across releases for an individual database, but also across databases within a network. Things Atlas actually cannot do. Yeah, let's just open that up. Got it. There we go. Aries, let's just take a step back. I also like the welcome screen, nice. It's a nice acronym, but of course also a Greek god. So here we have our one database loaded. So this is a data network view, one data source, 109 people, but you can have several data sources here as well. Let's go into the data source. The data source has one release, so these graphs are a bit trivial. Let's go into that one release. And there, yeah, I think these plots, Evanette already showed a sneak peek of these visualizations, these plots. We get a bit of a view of our population, 109 people, 49 males, 66 females, age at first observation, so these are pretty young people actually. This is confusing because a lot of had a pregnancy screening, so. This is like age at first observation. I see. Yeah. Distribution of race, and there we go, year of birth, which actually is quite well distributed, and apparently people are followed from quite an early age. But that just scratches the surface. We can look at so this is the person view. A very nice view I always like is the data density plot, which is also actually also an Atlas data sources, where we can see over time what data is collected in what domains, or how much data is available. Now we just have pretty small data set here, or small number of persons, so it looks not that nice, but let's just focus here on the measurement domain. And these are really nice interactive plots. We can zoom in into the last years and see the number of records over time. So here in August 2020, 660 records in the measurement table. What I always like now to look at these plots, do we see the effect of COVID? Now this is synthetic data, so we don't see it. But that's already a nice thing to see, like, oh yes, to confirm this is actual data. We see the real world here. You often see dips and peaks there quite strongly. So that's data density. Then we can also explore by domain, really get a feel of the data, what's in here, what's this population like. So look, let's load the visitor occurrence report, where we see there's 3 types of visits: inpatient, outpatient, emergency room visits. We can sort this table by percentage of persons with that particular visit. And what we see here, I find quite atypical, very critical. 86% of persons had an emergency room visit. That just characterizes our population as probably this is data from the ER or some critical facility. And we can even see by domain from what associated with what visit. You see, most data is associated with outpatient visits, which makes sense, I think. Also because all persons have an outpatient visit. Then lastly, let's also take a look at the measurement table where we can actually zoom even deeper into the data. So we see here all the measurements that have been done, 218 in total. As Evanette already showed, they all apparently have a blood panel, but I want to focus here on the heart rate because we actually also can see the distribution of values and just confirm for ourselves, like, well, yeah, does that make sense? Does that feel right? So here the heart rate lies between 53.6, which is odd that we have a not a rounded value, okay, until 199.1. I feel there's a quirk in the system there. Might be something to follow up on. Might be that's no minimum value. It's odd. Yeah. And we can see that also visualized actually as a box plot, which is basically the same information, of course. Sometimes measurements have multiple units, so then this would show up here as well. So that's the kind of visualizations that Aries gives you, and we can do that for all domains. You can even do comparisons across the network. It's really, really powerful. I have to admit, I've only just started using it, but it's really, really nice. It actually also, as I said, it loads a data quality dashboard in as well, showing you basically the same information as the native data quality dashboard viewer. It can do a little bit more. It's a little bit nicer to filter through, but all in all, it's very, very similar. That was Aries.
One thing I will say, the developer, Frank DeFalco, will be doing a software demo of Aries tomorrow. So if you want to learn a little bit more and ask him a little bit more about that, he will be around during the collaborator showcase.
Yeah. Then a little bit of self-promotion, as in there's one tool I've been working on myself for the Darwin EU network that I'm part of. And that's CDM onboarding. Again, an R package, open source. This produces a Word document that gives you the OMOP CDM database characteristics. And for us, that has been really useful evaluating data partners in the network, just giving an overview of the state of the CDM, basically. What tables have been filled, what's the concept mapping coverage, the data densities, and we have put in some quite specific things for our network. But it's open source. You're free to use that. One quite unique thing here is that it also looks at the database performance, query times, and also the infrastructure it runs on. What kind of database, how much memory, processing power, etc. But that as a small side note. Yeah, just to wrap up, actually, here we've shown now the whole ETL process from designing your ETL, making the ETL specifications, code mappings. Well, we've only looked in general at vocabularies. Come to Max's demo tomorrow on the Usagi on the web. That goes into depth on those code mappings. And then the whole ETL implementation, evaluation, which is actually a cycle that you should be repeating on each release, new implementation, evaluate, record any issues, fix those. Before we get to those final lessons, actually, what I was saying, yeah, ETL is a continuous thing. Most works upfront, creating this first ETL, but then you want to maintain that. The source data, the raw data might be changing or updated, requiring changes to the ETL specification, or just rerunning your ETL on new data. You might have found bugs in previous releases that you want to fix. New releases of the vocabularies, each 6 months there's a new release. You want to incorporate that, and sometimes that influences the logic in your ETL. Not always, but it could, because new mappings are made there. And once, of course, we have new CDM releases, that might also impact your data. So when the data model itself, the CDM changes. Yeah, so you're never done with ETL. It's always a maintenance process. Then to conclude some final lessons. The code mapping is often a time-consuming work, because there might be thousands of source code you're having, and going through these each manually, one by one, takes a lot of time to validate. Now with AI, good string-based matching, you might be a long way, but still a lot of work to validate as well. One thing to take into account is, I think, the Burrows principle or the 80-20 rule. Often by just mapping 80% of your codes, 20% of your codes you could do, you actually cover a lot of records. So for instance here, look at the top row, just 38.7% of codes here were mapped, unique codes, but it actually covered almost 90% of records. Bottom line here, focus on the top occurring codes. That brings you a long way, getting pretty good coverage. A lot of codes might not even be used in your data. Then, and Claire already talked to this, be comfortable with data loss. Throwing persons out of your, during the ETL process. For instance, if the gender or sex is unknown, might not be valuable for research anyhow, so drop them in the ETL. Make sure to document that. Drop them. Missing year of birth, or some default past date, like 1st of January 1900. Remove these persons from your data when going to OMOP. Maybe implausible years of birth, records before birth. You might be doubting then the data quality, throw these persons out. Gender changes I might not completely agree with, but in a data model here, it might be an issue, or for most research might be difficult to work with. But depends on your context, your use case, what you want to do here. Then, and these really are the last 2 slides, or actually last slide here, just to give you, if you're really interested in the topic of ETL and dive deep into this, we have 2 papers, I think both, well, one by Erica, one by Claire actually, on this ETL process, reflecting on this ETL process. Both from the Eden network, where we have mapped, or actually together with a big community, mapped almost 200 data sources to the OMOP CDM. 200. So there were a lot of lessons learned of the process. That's Erica's paper on the left. What expertise do you need? How much time is spent in each phase of the mapping? We analyzed that whole process of, I think there were more than 200 data sources even. Which was, really nice overview. And then we write the paper of Clair, where we publish on the data quality dashboard, how to use that to improve actually the data quality in such a network of data sources. I want to conclude there with the take-home message. The conclusion of that paper is that while study-specific checks should still be run, we recommend that all data holders converting their data to the OMOP CDM use the data quality dashboard as an assurance conformance to the model specifications, and that the database meets a baseline level of completeness and plausibility for use of research. And that's what all this evaluation is for. Thanks. That's the end. I'm not sure, Claire, when you want to conclude?
Thank you, everybody, for hanging out with us. I kind of lied. I thought we were going to get out early, but you guys had really great questions, so we lasted the whole time, and thank you for staying with us today. So we will be around. There's a networking event from 6 to 8 this evening, so if you want to come take a first look at the posters, they're going to be available. I forget where. Does anybody remember where the posters are being set up? The name of the place? I should have looked it up before I started speaking. But in the place where the posters are, the Garden State Room, I knew it was a thing like that. We're having our networking event, so we'd love to see you all. Thank you again for hanging out, and we'll be around if you have more questions.